No correspondiente. English and Portuguese speaking people in the room, please follow the instructions sent to you. Para comenzar, estamos en el Salón Andrés Sabella Galvez de la Universidad Católica del Norte y queremos invitarles a ver un video de seguridad.
Procurando cubrir nariz y boca. Se debe respetar el distanciamiento físico de al menos 1 metro lineal. Se dispone de alcohol gel para su uso en todo momento. Abstenerse de tocarse los ojos, la nariz y la boca. En caso de ocurrir alguna emergencia, se debe evacuar hacia el punto de encuentro de evacuación. La evacuación debe ser de forma tranquila, sin correr, siempre respetando el distanciamiento físico y utilizando adecuadamente mascarillas. Esperar en el lugar hasta recibir instrucciones del encargado. Y por último, silenciar sus teléfonos celulares durante toda la ceremonia.
Queremos darles la cordial bienvenida al Seminario de Recursos Naturales, el tercero de la serie, Datos satelitales de Copernicus en Chile y América Latina, construyendo aplicaciones y redes de colaboración. Este seminario es el primero que tiene una modalidad híbrida, con sesiones presenciales y participación en línea. Es así como este primer día nos encontramos en el Salón Auditorio Andrés Sabella de la Universidad Católica del Norte, en la ciudad de Antofagasta, quienes nos ha acogido para llevar a cabo esta actividad. También estamos de forma interactiva a través de la plataforma Zoom. Esta iniciativa es organizada gracias a una colaboración financiada por el programa Marco de Copernicus de la Unión Europea, Centro de Modelamiento Matemático de la Universidad de Chile, en representación del Centro de Referencia Copernicus Chile y el Comité Nacional Conjunto para la Conservación JNCC del Reino Unido. En particular, este seminario está siendo organizado entre los ya mencionados y la Universidad Católica del Norte, la Universidad del Biobío, la Universidad de O'Higgins y el Centro de Modelamiento Matemático. Para dar inicio a este seminario llamado Recursos Naturales, queremos dar la bienvenida a la Directora General de Vinculación con el medio de la Universidad Católica del Norte, Olga María Valdés de la Torre, en representación del rector, doctor Rodrigo Aldavaras.
Muchas gracias. Pedí permiso primero. Muy buenos días a todas y a todos, a los presentes, a los que nos están viendo en línea. Le damos la más cordial bienvenida a nuestra casa, a la Universidad Católica del Norte, y en especial a este seminario que a través nuestro, la Escuela de Negocios Mineros, está organizando. Traigo un especial saludo de nuestro rector Rodrigo Aldas, que le expresa todos sus parabienes, les desea el mejor de los éxitos en esta jornada, y lamenta no estar presente por cuanto tenían actividades que son impostergables que exigían de su presencia. Quiero saludar especialmente a los expositores de este taller y el director de la escuela, don Ítalo Montofred, por la gestión realizada para poder llevar a cabo esta iniciativa en nuestra universidad. El objetivo de Copernicus concuerda plenamente con los lineamientos estratégicos de nuestra universidad, que tiene que ver con cómo conservamos, aportamos a poder construir una sociedad que respeta, resguarda el medio ambiente. Nuestra universidad, además de tenerlo como un pilar fundamental en su plan de desarrollo estratégico, lo hace a través de la formación de profesionales con un sello distintivo, que es la responsabilidad social que marca todo, no solamente con el otro, es el todo. Responsabilidad con nuestras tierras, con nuestro territorio, con nuestro ambiente. Y también el sello de respeto, respeto por la dignidad de las personas. Por su parte, Copernicus, a través de tecnología satelital, va a estar observando nuestra tierra para ver todos estos cambios ambientales y entender mejor por qué se producen, más allá de la responsabilidad que podamos tener nosotros las personas, porque gran parte de todo esto lo hemos causado nosotros mismos, y lo sabemos. Pero también observar y ver cómo estos cambios medioambientales están impactando nuestras vidas y cómo contribuir a la protección de la salud, obviamente el medio ambiente y por supuesto la seguridad de todos quienes habitamos este planeta. A nivel global, hemos evolucionado bastante con el tema del uso de satélites. En algún momento fueron con temas de comunicación, pero hoy día su tecnología nos está permitiendo desarrollar y avanzar en información que nos permita comprender, desarrollar investigación que sea relevante según los territorios en donde se enfoque. En nuestra región, en lo particular, por ser la región minera, se centrará justamente en la minería, para poder observar cómo se desarrolla también el impacto que puede tener nuestra industria. A nivel ya más al sur, entre Talca y Rancagua, serán los aspectos vinculados a la agricultura. En Chillán, con la industria forestal, y en Santiago, una problemática que está presente en todo nuestro país, pero que se hace más latente el problema en esa región, dada la población que tiene, que es el agua en la región metropolitana. Necesitamos avanzar a un mundo distinto, a un mundo donde las energías limpias prevalezcan, en que la conciencia de cada uno de todos y todas sean un aporte de construcción de un futuro mejor. Esto no es un eslogan que nosotros escuchamos, yo escuchaba hace muchos años atrás, del futuro mejor para nuestros hijos. Ya estamos viviendo una situación que hace y nos exige tomar medidas desde distintas líneas, ya no solamente los ingenieros ambientales, sino que de las distintas profesiones, oficios y lugares que estemos, tenemos que contribuir porque estamos palpando los efectos del cambio climático. Lo vemos en las lluvias, por ejemplo, en China que están realizando, en India que se están dando, en Pakistán. Por lo tanto, somos conscientes ya y debemos ser conscientes de esto. Nuestra región Antofagasta tiene, bueno, Chile en general, pero especialmente la región de Antofagasta, tiene reservas connotadas a nivel mundial de cobre y de litio. Dos minerales que aportan efectivamente a toda la generación de energías limpias, a toda la transmisión fotovoltaica. Las baterías de litio se dice que son el recurso del futuro, ya se están utilizando en distintos ámbitos. Nuestra universidad tiene una fuerte ligazón con este tema, estamos partiendo con un polo de investigación del uso y reciclaje de baterías de litio, por lo tanto, es un deber de todas y todos poder hoy día investigar para avanzar, no solo extraer, producir y ganar. Tenemos que ver cómo lo hacemos de manera sostenible y sustentable. ¿Estamos claros? Al final no leí nada, me puse a conversar con ustedes. Estamos claros del deber de todos. Si todos nos juntamos, ciertamente el desarrollo va a ser distinto. El desarrollo ya no va a ser concebido como hasta hace una década atrás, que tenía que ver con el ingreso per cápita, que tenía que ver con el dinero, la inversión que se realizaba. Hoy día también el desarrollo está asociado por una mejor calidad de vida. Una mejor calidad de vida que significa los ingresos, la salud y, por supuesto, el resguardo del medio ambiente. Mis deseos de mayor éxito en la actividad. Les agradezco estas instancias que son ricas tanto para nuestros estudiantes, como nuestra comunidad, como para toda la sociedad. Y nada, bienvenidos a la Universidad Católica del Norte. Gracias. Sí.
Agradecemos las palabras de la directora general de vinculación con el medio de la UCN, Olga María Valdés de la Torre. Seguidamente, dejo con ustedes al señor Matt Smith, gerente de Biodiversidad, Ecosistemas y Capital Natural del Young Natural Conservation Committee del Reino Unido, quien se dirigirá a los presentes.
máscara. Buenos días, bienvenidos. Mi nombre es Matt Smith. Soy biodiversidad, ecosistemas y capital natural gerente a JNCC. Muchas gracias a la universidad por invitarnos y a Ítalo y colegas por su apoyo para hacer posible este evento. Por el bien de los traductores simultáneos y para salvarlos mi horrible español, disculpe. Habla en mi idioma nativo, inglés. JNCC is the Joint Nature Conservation Committee. Our function is impartial scientific advisors to the United Kingdom and the devolved administrations of the United Kingdom, that being Scotland, Northern Ireland, and Wales, and also the overseas territories. Our focus of our work is very much providing scientific advice and support around the sustainable use and management of natural ecosystems, both in the UK and internationally. This is our third series of 4-day workshops, which has been delivered in collaboration with our colleagues at CMM at the University of Chile. And we're incredibly grateful for their friendship and their partnership for this collaboration and helping this event take place in this wonderful country of Chile. Our program is funded by the European Commission via the Framework Partnership Agreement on Copernicus user uptake. Now, this program has 175 actions currently running with over 50 consortium members. Now, the Copernicus program may be known to some of you, not to all, and that's why we're here today to discuss. So the Copernicus program is based upon data services that are provided by 6 families of satellites, which are known as Sentinels. The program has accompanied data services which supports the use of Earth observation, remote sensing data in decision-making. Now, these services include atmosphere, marine, land, climate change, security, and emergency response, I should say. So the purpose of our events are quite simple. It is to present the use cases of Copernicus data, of which we have some of our esteemed colleagues here with us today from various countries around the world. To present the use cases and to stimulate conversations on the use and the application of this data, both in Chile and Latin America more widely. So this conversation is to help identify pathways for collaboration, and also to show yourselves here in this room and those online who are joining us today, how this open access and free to use data can help both yourselves in research, in your work, and in decision-making more generally. We really want to capture these ideas through the later discussions that will be held. My esteemed colleague Florencio Ortreas is in Santiago at the moment, and he will be helping those of you online to raise your questions and contribute to the discussion. So please do stay engaged for that part of this event. We would encourage the exploration and use of data alongside to complement the existing data and knowledge that you are already using in your work. This particular series, as you can see, is focusing on natural resources. We have 4 excellent speakers here for you today. And I would urge you, if you haven't already, please do register and listen to our remaining events. We've already heard this will be on forestry tomorrow in Chian. We were then going to Rancagua to discuss agriculture, and then finally in Santiago, water as a resource. You can also see the past workshops, which were on climate change and natural disasters. These have been recorded and made available. And after this workshop series, we will make sure that we send a link to all of the outputs to our mailing list of registrants. So all I need to do now is to really ask you to enjoy the presentations. They really are incredibly interesting. And most importantly, please keep your minds active for the general discussions later, because we're really here to hear your ideas. It's as much about us imparting knowledge, but you also to impart your knowledge and help build these collaborations and pathways for making better decisions for our ecosystems that support everybody on this planet. So yes, I shall leave it there, and hope that this fruitful discussion really will increase the use and the uptake of this valuable resource of Copernicus data. Thank you very much.
Agradecemos las palabras de don Matt Smith, gerente de Biodiversidad, Ecosistemas y Capital Natural de Young Nature Conservation Committee del Reino Unido. Quien presidirá esta sesión es el director de la Escuela de Negocios Mineros de la Universidad Católica del Norte, don Ítalo Montofré Basigolupo. El doctor Montofré es ingeniero en minas y licenciado en Ingeniería Aplicada de la Universidad de Antofagasta, con más de 30 años en el campo laboral. Es doctor en Medio Ambiente y Minería Sostenible de la Universidad Politécnica de Cartagena, en España. Es académico del Departamento de Ingeniería Metalúrgica y Minas, junto con pertenecer al Núcleo de Investigación, Desarrollos Tecnológicos para la Gestión de Residuos Naturales, residuos mineros, bien digo, fundamentalmente relaves. Actualmente, el doctor Montofré es director de la Escuela de Negocios Mineros de la UCN, siendo un gran colaborador en esta iniciativa. Damas y caballeros, dejo con ustedes al director de la Escuela de Negocios Mineros de la UCN, el doctor Ítalo Montofré.
Muy buenos días a todos y a todas. Permiso. Antes que todo, quiero agradecer a nuestra universidad, a nuestro rector, por el espaldarazo dado a esta actividad. Y también agradecer a la Escuela de Negocios Mineros, agradecer al JNCC que dirige Matt Smith por creer en nosotros, y a el Centro de Modelamiento Matemático, en que don Florencio Utreras y Jaime Ortega han creído en nosotros. Aprovecho de saludar también a Sara Camayes Yetvi, a Felipe Lobo, a Jaime Ortega y Tara Marcelju. Antes de proseguir con la actividad, voy a dejar con ustedes, desde la distancia, a don Florencio Utrera, a don Jaime Ortega, entonces, para que en representación de el Centro de Modelamiento Matemático nos pueda dirigir unas palabras. Por favor.
Hola, buenos días. Bueno, primero los agradecimientos nuevamente a esta casa que nos recibe, la Universidad Católica del Norte. Agradecimiento a Ítalo y a toda la gente que ha hecho posible que estemos aquí. Para nosotros un tremendo gusto el tener este pequeño workshop que estamos viendo hoy. A nombre del CMM y la Universidad de Chile, quiero agradecer la asistencia. También contar que este es el tercer workshop, como decía Matt, pero es el primero que podemos hacer presencial. Es la primera vez que nos estamos viendo la cara y vamos a compartir y conversar sobre distintos temas, en particular como este programa Copernicus, del cual vamos a hablar a lo largo de esta sesión, está disponibilizando datos completamente abiertos, completamente gratuitos para diferentes aplicaciones y principalmente en el día de hoy vamos a conversar de minería en una ciudad que es la capital de la minería en Chile, como es Antofagasta. Así que nuevamente quiero agradecer a nombre del Centro de Modelamiento Matemático de la Universidad de Chile por acogernos y por todo el apoyo que hemos tenido para tener esta fiesta hoy en que nos podemos ver las caras y hacer un poquito de ciencia todos juntos. Muchas gracias. Gracias.
Muy bien. Dicho aquello, vamos a dar inicio entonces a la actividad formal. Vamos a presentar a la señora Sara Kamayazdi, investigadora del Departamento de Ingeniería Civil, Química, Ambiental y de Materiales de la Universidad de Bolonia, Italia. Sara es ingeniera minera, obtuvo su doctorado del Departamento de Ingeniería Civil, Química, Ambiental y de Materiales en el año 2017. Es ingeniera minera geoestadística con la colaboración de Mining Paris Tech. Su postdoctorado lo obtuvo en GeoResearch. El 2018 ganó la propuesta de conectar los datos de observación de la Tierra con datos Copernicus, con muestras in situ de residuos de bauxita y ha trabajado en la caracterización de las materias primas críticas. El objetivo de su proyecto fue la interacción de muestras in situ y de los datos de observación de la Tierra para la optimización de muestras utilizando herramientas geoestadísticas. Ha trabajado en varios proyectos financiados por el EIT de Raw Materials como investigadora principal y ha sido además investigadora de la Universidad Tecnológica de Luleå en el año 2021. Dejo con ustedes a Sara Kamayazdi en su tema Using Copernicus Data Within the Raw Materials Life Cycle. Please.
So, good morning, everyone, and thank you very much. My special thanks to all host institutes to invite me. I'm very happy to be for the first time in South America and in your beautiful country. And I hope in this presentation we can learn from each other. I'm here just to share with you my own experiences, what I did in the last few years. And I'm sure that we can grasp some ideas with each other within the topics which I will present to you. And afterwards, we can go on with developing more things and more advanced techniques using Copernicus data, specifically in mining. So thank you very much to be here. So in this presentation, I will present you, first of all, who we are, the group which I'm come from, the Raw Materials Copernicus Academy. And then I will present you why do we use Copernicus data, the advantages, the objectives we have. And afterwards, I will present you how do we use these Copernicus data in the whole life cycle. So I will start from exploration, and then we go through excavation, following the material flows inside mines and ground stability and monitoring of mining. And we arrived to even the mining tailings stockpiles. And afterwards, we finish with environmental monitoring. So I try to share our experiences in the whole life cycle. And I hope we can learn from each other, and afterwards we can go on with some new flash and new ideas. So yes, here it's our group. I'm just one of them, and be lucky to be here to present the whole group. So we are 6 researchers from 6 different institutes in Europe, from Italy, Sweden, Spain, Belgium, and Germany, from all research centers and universities in different parts of the Europe. And I will go within all projects, and I will share a summary of what each of us did within these years inside the Raw Materials Academy group. And here you can see all projects we did. We did around 12 projects. Each were just for 1 year. And each year we were applying for a new idea, a new project. So if you need more information about any specific projects, you can even visit our website. But in this presentation, I will go through each proposal and each project, so you will know a little bit what we did. So to present myself, my name is Sara, and I did my PhD in from 2014 to 2017 in University of Bologna in Italy. And my main expertise is 3-dimensional modeling of ore bodies using geostatistical methods. And during my PhD, I worked with University of Sapienza in Rome, and I spent some time also in Mainz, Paris Tech in the Center of Geostatistics. And afterwards, you see, I worked on different projects. Some of them were European projects, and the other were funded by ET Raw Materials. And since 2018, I started to use the Copernicus data in my work. And I'm here now. So let's start. Why do we use Copernicus data? Why do we need such data? And what is the objectives? And what can be the advantages of using such data? Unfortunately, mining is still an old-fashioned sector in many countries. Still, in the view of social people and the normal people who don't know professionally about mining, they think that mining is an old-fashioned. Some of them might think even it's just a big hole or some galleries. This is what people might think still about mining, but especially from the point of view that in a mining countries, it's very important that we change this aspect. We use the available advanced tools and techniques to be more friendly, more environmental friendly, and show that even in mining that still is considered an old-fashioned sector, we can use high techniques and high tools for developing the methods. So it's very important that we use the advanced techniques in our sector. On the other hand, we are facing a lot of challenges in mining, and let's review just some of these challenges. We have always facing with environmental hazards in mining. Yes, we many times in all around the world, we are facing with some disasters like the tailing dams collapsing, like acid mine drainage, the seepage of this acid mine drainage on the groundwater or rivers. So we see that they affect importantly the social acceptance and the social attitudes toward mining. So we need some monitoring tools, some real-time monitoring tools to monitor the mining activities and to stop such hazards. Another one we can mention to ground subsidence caused by mining activities. Most of the time it happens nearby the mining area. And why not monitoring the movements of the ground or the pit, the open pit, or even the tailings? And we need some tools to do these updating monitoring to see how the ground is moving around the mining activities we are doing. So this is another environmental hazards we should take care of it in mining. Then, yes, mining activities are very costly and damaging sometimes. Even if we start from the exploration, we are starting from a large exploration areas. Many times they are hard to access there. Sometimes they are covered by ice or not accessible slopes. And for arriving to a real economic deposit, we need a large sampling. And most of the time, these samples are damaging the area. And at the end, we arrive that, okay, this area is not economic for starting our mining activities. So it's very important that we focus on a smaller area, but a smarter area. It means we go with untouched techniques toward our target area with a smaller area, and then we can still use some techniques to optimize our sampling, for example. So with less samples, we get higher information. So these can be some solutions for that. Or if we go to the next step, which is excavation, yes, we still are facing with mix of materials while blasting. And many times, specifically for the stockpiles and tailings, we are facing with the disordered pilings because they are just low-grade materials and we need to monitor them. We need to record how they are piling and where they are piling. And in the future slides, you will see why these aspects are important. So we have in mining sector a lot of challenges in all around the world. We have all these challenges in almost any mine in a small scale or bigger scale in all around the world. Mining is costly and damaging activities. Sometimes we are facing with a lot of hazards during the mining activities and after the mining closure. So we need innovative tools and techniques to improve our activities, to be more acceptable for the society and more efficiently, because we are facing to the high demand of raw materials and these resources are not infinite. So one day they all will be finished. So we need to be smarter, faster, more green, and more efficiently with all the sources we have. So the Copernicus data can be one of these solutions we can use today. And yes, when we use this Copernicus data, we can go toward the smart monitoring of mining activities from exploration, excavation, and even the post-closure activities. We can focus on a smaller area for exploration and prospecting. We need to use less samples and more efficient sample grid. We need to take care of the stability of our open pit and the materials flow. And at the end, we need to take care of our stockpiles and tailings management. This is the summary of just partly let's say, partly of the challenges and the advantages of using this Copernicus data in our work. You might probably know better than me. I just brought some slides about the Copernicus. So Copernicus program is a European Union's observation program, and it's managed by European Commission, and it's collaborated with European Space Agency and European member states and European agencies. And if you go within their websites, you enter to a new world with a lot of information, with a lot of catalogs about their products, their data, how you can access easily to those data, and so on. So the program, as here you can see, there are different types of satellites with different applications. You can use them, and they are continuously collecting of data by free. So it's just like creating an email account. You can just create an account in the website of, for example, ESA. You can enter, and then you enter to a new world. You can catch any image from any part of the world, from the dates you need, and for the application you need. So here you can see you can use for atmospheric, ocean, and land monitoring, and so on. Here you can see some information about the different satellite sentinels I brought for you. So I in this presentation will focus mainly on Sentinel-1 and Sentinel-2, because our experience is using these two satellites. So I will share our experience. And they started from 2014. And Sentinel-1 has the day and night imaging mission, and it covers for the land and ocean services, while Sentinel-2, which is an optic satellite we use for detecting and studying the vegetation, soil, water, and especially inland waters like rivers and the sea. So you will see in our applications how do we use these data. So if I start to present you the ROMATSCOPE Academy, as you saw the member of the group, we are belonging to a program which was funded by ET Raw Materials and DG Grow. And we started from 2017, I think. I started in 2018. So we use the Copernicus data mainly, but you will see we need other types of data for our work. And we try to develop some algorithms or some methodologic tools for using in different parts of mining. And we go through it now. So the first researcher was Mehdi. He was a postdoc researcher from Luleå University in Sweden. And he worked on two projects, mainly on IOCG deposits in Greenland. He had his case study in two areas of Greenland. And here you see the title of his projects. So if we go within his projects, he mainly focused on IOCG deposits. So he tried to do the mineral potential mapping for exploration of iron oxide, copper, gold mineralization, which is quite important because of multi-metal deposits of it. And in the first case study, he focused on the north of Greenland in an area that he used different types of data. He used Sentinel-2 satellites for the detection of different minerals like iron bearing and clay. And he also used the airborne magnetic data. He used airborne time domain electromagnetic data. He used also geochemistry data from the sediments and the rocks in the area, and also the lithological maps that here you can see. Oh, sorry, we should come back. Yes, okay. So as you can see here, he tried to produce different results. From the satellite data, he tried to detect the iron oxide, and also he created the lineament analysis map, which is used, as you can see, the last one. On the left, he tries to recognize the fracture, the tectonic structure of the area, and from the geophysical data, he created other layers for his work, and his target was detecting these iron-bearing minerals and clay in the area to see if there is the possibility for the future exploration. And as you know, the Greenland is quite challenging for exploration because most of the time is covered by ice, and is not easy to access to the areas of Greenland during the year. So his final results were these maps, and the most important one, the favorability map. So as I mentioned, instead of working in a large area, he could focus more in a smaller area with higher probability of finding iron and the higher concentration minerals in that area. So he used these three methods. He used the support vector machines and self-organizing maps. Mostly he used the machine learning algorithm to create his target maps. And afterwards, he compared his results with some in-field samples and geological map, and they showed that there is a coherent between the geological maps and his favorability maps. So some of the areas are, you can see that there is the mineral occurrence already known in the area, and he could find some new areas that it needs to do the field check and validation for the future explorations. And then his second case study was on the east of Greenland, as you can see. And this time he used his first experience, from the methodologies he did from the first project in the second project. And this time he used the deep learning methods to classify the area, and he divided his results into two parts: molybdenum deposits and surrounding area, and at the end, the other area, which was the multi-metal zones. So you can see the lead, zinc, and copper areas were detected in this part. So he did this work in exploration. We can stay still in exploration, and then for mining monitoring, she did some interesting work on the dust dispersion and using remote sensing for mapping the outcrops. And she tried to quantify, using the satellite data to quantify the maps. So Elsie was a researcher from University of Liège, working on these two projects. The first project was on Tibagi in the nickel mine in New Caledonia. So this was her case study. And she used different types of data like drill holes. Then she had the data from spectra of all drill holes. Then she used Sentinel-2 images and and the chemical composition data. So what she did in this work was she tried to use the spectra of samples from drill holes and we make them close to the properties of the satellite data, which we have. Then she fit a regression function on that, and she tried to predict the concentration of iron, aluminum, and nickel, magnesium in her area. So afterwards, using it, she tried to extend it in the outcrop, and this area you can see is the area that she mapped them nearby the drill holes she had. And afterwards, she did a comparison between her results and the indices maps directly from Copernicus data from the Sentinel-2 images. So she mapped like the iron index from some simple calculations that we call it band ratio. And then from the regression, she tried to map the iron, and she, comparing them together, understood that they have a well coherent, and so we can use them with her methods to quantify almost the outcrops in an area. Then in the second case study, she tried to monitor illegal mining in Colombia. So she visited 2 times her case study, and then she tried first to understand what is the process of these mining activities there, because this project, I think, yes, it was also funded by UN. So they were trying to understand in which areas illegal mining is expanding, and she tried to first understand how they work. So from the placer mining, she understood that they create some ponds and they fill them with water. So since ponds are quite large and the resolution of these images are 10 meters, so she tried to classify the images she had to detect these ponds. So in this way, she could recognize where are these illegal mining activities going on. And afterwards, with visiting the fields, they could do some validations and to understand what's going on in the local area. So as you can see here, she tried to classify her maps into different classes. So to vegetation, that we can detect it easily from the data we have. Then the soil, the ponds, and with this, in this way, she could recognize those areas which were affected by this illegal mining. Because also we know that many times these type of illegal activities, they affect the soil nearby the mining activities. So her target was detecting these parts. Then Louis, he was a researcher in Helmholtz Institute of Freiberg in Germany. And he worked also on 2 projects. One was using Copernicus data for exploration. And then on the second project, he tried to detect the volume changing. So to detect which part of the mine is changing, but not directly from the satellite images. So he could study the changing of the volume of the pit and dumps and so on. So he enters to the excavation step. So here you can see he had a case study in Rio Tinto in the Iberian Pirate Bay belt in Spain. So as you can see, he used the Sentinel-2 images, and he used different methods to detect again, the iron bearing, and specifically he was focusing on acid mine drainage. So to detect the acid mine drainage, to separate it from the clean water features, and to detect how they are changing. So he was doing like a monitoring of these acid mine drainage in that area. He used band ratio methods. It's just a simple calculation between different bands in a pixel. So you can make it easily, and with a good detection, you can see if areas are affected by iron or not. So even inside the water features, it's possible to detect, because the jarosite is a mineral which we could detect it inside the acid mine drainage, and it's possible with using the band ratios to detect it. As you can see, this is a river close by, and it's completely clear that is affected by acid mine drainage in that area. So he also used other techniques like spectral angle mapper, the other machine learnings. So she started to use some field data he had, and most of the time we have limited number of field samples. So using these field samples, and on the other hand, a huge number of the satellite images, he could detect his targets area and the targets features. So he used different methods like random forest, the support vector machine, and afterwards he did a comparison with the infield samples he had to see how much they can be valid. And in many areas, his validation results were coherent with the infield samples. And then in the other project, he focused on integrate actually the Sentinel-1 and Sentinel-2 images together. And he tried to use these data for several months. So he again used this spectral angle mapper tool for detect between different images. So for example, he used several images, and he tried to see if the angles between these images is, the difference is high, so it means that the place is changing, or if the angle is low, it means the place or the area is not frequently changed. So without, let's say, touching the area, he could monitor the open pit areas, which they were regularly changing by excavation, and also he could monitor how stockpiles are piling beside the open pit. So with his methodology, he tried to detect these changing areas in this Rio Tinto mine. And in the last one, yes, unfortunately, since it's the PDF, you cannot see, because he created a moving image in this area that it was changing. So you could see how topography of the area is changing by mining activities. And to use, when you use a high number of images, you can do this monitoring, and In this work, actually, he tried for the first time doing the digital elevation model, this time from Sentinel-1, which is quite challenging because we don't have regularly very close images in a short time. So he tried to apply this method in his case study. And he had also the LIDAR data. So at the end, he was doing the validation of his results with LIDAR data, and moreover, to see if the changing of the volume is coherent with the data, with the infill data he had. So on the left, you can see the digital elevation model he created, and it shows the changes in elevation for 5 years. So he tried to monitor and to use these 5 years images together and to create these topographic profiles, and then fitted with the LIDAR data, which are these profiles you can see. And yes, the most difficult one for me is the Ignacio's work, because he worked in radar in Sentinel-1, and actually he worked more than all of us. He worked for 3 years project, and he did a big effort to develop some automated tools for radar, and you will see here about his work. So his objective was to monitoring the stability of mining activities. He chose, let's say, a calm area, a dump nearby the mine, not an active part, because he wanted to check if in a calm area, the mining dams they have even some millimeter movements in the area. So he chose an area around the pit, but mainly on the dams. And he used the SAR data, the Sentinel-1, and seismic data for his work. So he used around 33 images of Sentinel-1 from 2015 to 2017, as you can see. And his case study was in Atalaya open pit in Spain. And dots here, as you can see in his map, these dots are presenting the mean velocity values of each cell. And it shows how the areas are stable or they have some movements. So actually, he tried to create an automated tool to detect the areas which have movement or they are stable. And in this methodology, you can put a threshold, and if the movements are more than the threshold you need, they will be like an alarm to mention that here the stability is in danger, and there is a need of monitoring, and there is a need of a higher attention to the area. And as SAR data are mostly so big data, they have they need a powerful processing server, and it's very difficult to processing them. He tried to develop a tool for automate or to automize them. So he created a software, a tool, and within his tool, it's possible to download all images automatically from the area you need. And afterwards, there is the possibility of pre-processing of this data. And actually, he tried to simplify the use of Sentinel-1 data in his work. So they checked it with a PC in their university, and he created like a platform that you could join and you can use your data within their server, and afterwards he could create the results for you without huge processing steps. And he did let's say the testing of his methodology and tool in 4 mining targets in the area, and some of them were quite satisfying, and I think he was still waiting for the rest of the feedback from mines he worked with. So this was big work of Ignacio. I hope I explained well, because I'm not so aware of Sentinel-1 work. So here I'm happy because finally I can present my work. I worked on 2 projects. The first one was sampling optimization in stockpiles, actually in tailings. I will show you. And the other one was characterization of these tailings. So the point is that the main key of my projects were the need of raw material sources. So what we are thinking in Europe is to think about the remaining stockpiles and tailings, not as tailings, but as resources. Because once the low-grade rocks were just piled in some areas, but now we have high technology in processing to recover them. On the other hand, we are going to face with a lot of challenges to have resources of critical raw materials. So what we are thinking is to going back to these tailings and to these stockpiles and see if we can recover some critical raw materials from them. So my case study was in Greece, in tailings of bauxite, as you can see here, in a very beautiful Gulf of Greece nearby Athens. And the tailings are 100% dry. So they passed it through 6 filters. So they are dry and they are cleaner than the other normal, let's say, bauxite tailings. And every day there is the trucks who pile the materials which are tailings from the bauxite processing in this area. And my target was to study and to find out if there is the possibility of recovering some critical raw materials. So I had some chemical analysis of the data, and I started to search for iron, aluminum, which were the main elements there. And there were some correlations between them and titanium and vanadium and the other critical, let's say, elements there. So what I did was using Sentinel data to follow how these piles are created. So we could recognize how they were piled. And then since we have just few samples in the field, as you can see, I could use big number of these satellite data to create a correlation and to find the correlation between them and the in-field samples. And I could predict the grade maps or the concentration map for the even the critical raw materials elements like vanadium and titanium. And as you can see here, for example, you can see it's for aluminum. It shows which part has a higher grade and which part has a lower grade with the variance map. And then I could also create the volume of these piles thanks to the stereo images of a Palladius satellite image. So I used both the high resolution images and the Copernicus data. And I replicate my work on another case study in south of Italy. And the interesting thing in this work was that we tried to use these old stockpiles and tailings to find out if we can go to an exploration, a new area in that part. So we could detect some area even inside here it was a forest, and after validation with the field data, we could see that yes, there is the traces of aluminum in that area. And okay, and the last one is Christian. Christian is a researcher in University of Freiburg, and he worked only on one project, cómo, in 2018. And in his work, he started again to integrate. It doesn't go on. Please, next. It's not me. Okay, thank you. So he tried to integrate Sentinel-1 and 2 in an area in Germany, which here, as you can see, the blue line is an oil pipe. And he tried to detect if it's possible for monitoring the area and to detect the pollution affected by this oil pipe. And he tried to make a software to automatize the procedure. So for acquisition the images, for processing, and even he put some algorithms for detecting the outliers. So in this way, he could detect where and which pixels are outliers and which one are the, let's say, the pollution. And as you can see here, the yellow and the red pixels, they show the high risky areas in this case study. So yes, I overview almost from exploration to the monitoring system of mining. You could see that there is a huge possibility of using Copernicus data in almost all parts of the mining. So I'm sure, especially in your country, you have incredible mines. So you have much better applications than us to create these ideas, to develop these tools, and to go on with more advanced techniques in your mines. So just to sum up what we learned, so as you could see, there is the high potential for developing the monitoring to reduce like the monitoring costs, to increase the public awareness by using this Copernicus data in mining. And this is quite essential, especially with all environmental issues which exist in mining sector. And as you could see, Sentinel-2 has a high capacity for monitoring, for detecting the acid mine drainage, for short time, and also for the real-time monitoring, as did Christian. And using this Copernicus data, which are quite free, and we have a huge amount of this data, it can help us for suitable planning for our mining activities. We can have efficient tools to study all mining activities, to stop illegal activities, and for monitoring the impacts of the landscape, the contaminated area, and so on. And yes, we can help for exploration of new resources, so to be faster, smarter, and more efficient. For exploration activities, we can do monitoring, and we can detect the alerts of different areas around mining if there is the movement in that area, so to stop the environmental hazards in mining parts. And we can have these monitoring tools for a longer time, even for the future and for our future activities, and specifically study the contaminated area around our mining activities. Yes, here you can find our group paper that we shortly explained our work. but each of us, we publish at least 2 papers about all these projects, so you can easily catch them and study specifically about the methodologies and details of our work if you need for your work. And finally, I will present you the courses we have. So during these projects, we were happy to present our experiences within some courses. We had the 2 physical short courses, first in University of Liège and the second one in University of Bologna. Afterwards, COVID arrived, unfortunately, and with a huge, let's say, effort, we moved everything to an online course. And it was very difficult because we wanted to have an interactive course to not be just a teacher in front of the PC and others just sleeping. And fortunately, we were somehow successful. The feedbacks were very positive. So they asked us repeating and repeating and repeating the course. So we did it more than 5 online courses after 2018 up to now. The next one will be just in October, if you are interested. And we did for Geological Survey of Germany, Portugal, Spain, for some universities in East Europe. So yes, this was, here you can see just the catalog for the University of Košice in Slovakia. So we did this in 2020. And this course was the basic course. So all we learned within our projects, we were transferring to participants, and they were from all groups, researchers, professors, students, or even people from companies who participated. Every day we had also some key speakers and some real case studies that students, they could work on it. Yes, this was our cake. And fortunately, this project will go on. So since the course was successful, they asked us to continue this project. And we started the new project just in July. And we are trying to, let's say, design advanced course, because many participants after that they ask us for advanced course. So hopefully we will do this year, and this year still will be repeating of the basic courses, but from next year hopefully we will have an advanced course, transferring our knowledge to participants. That's it. Thank you very much. I hope you could grasp some points from our experiences. I'm sorry if I made some errors about my colleagues' work. And I'm here to, if you have any question, I hope there is time for it. Thank you very much for your attention.
Ok, vamos a pasar entonces a la etapa de preguntas. Por favor, adelante. El micrófono, por favor.
For the rest of people, you can hear in English? Or I can do in English and in Spanish.
Thank you.
Sí, no, una cosa, congratulations, very nice.
Thank you.
Muy interesantes, fueron muchas aplicaciones distintas, a lot of applications. Algunas de ellas, some of them, usas no solo imágenes de Copernicus. You don't use only Copernicus image. You use commercial ones, Pleiades o Terrazar o others.
Yes.
¿Qué tan dependientes? How much depends los resultados del uso de estas imágenes? How much depends? Porque, solo un punto. En Sudamérica no tenemos mucho acceso a muchas imágenes comerciales.
I see.
En comparación con Europa.
Yes, I see.
Te comentaba, RadarSat,
Mm.
puedes presentar un proyecto, you can present a project para obtener imágenes RadarSat, but if you live here in South America, si vivimos por acá, no son posibles, por eso
I
un poco. ¿Qué tan dependientes son? How much depends of this kind of image?
Of course, you might know better than me. It depends to the scale of your work and the precise of the results you might need. Of course, in some of these works, we had to do some of the commercial images, not all. Some of them were fully with the Copernicus data, and we used even the software of ESA, SNAP, the free software available for all. So our challenge was going to the place and in-field samples and, you know, the validation, since we were doing scientific work. So you know that when we are doing a scientific work, we need a high validation. So for that, for example, we go one step more. We use some commercial images to see the let's say the higher resolution features. So we need it sometimes even just for validation. But of course, it depends to your application, the precise of your results, the validation you need. And I think from one side, we had to use, because for us, the more challenging was touching the area. Like, for example, my case study was in a region park in Italy. So they were saying, this is a park, what do you want to do there? But so because of that, instead of going and taking a lot of samples, I had to use higher resolution images for validation of my work. But here, I think you have less this challenge. You have more in-field samples, and you can reach to the field. And I think your scale is completely different from our small applications. So, yes.
Aquí, allá, por favor. Solicitamos también a los participantes en líneas que indiquen en el chat la pregunta o con el icono levanten su mano para atenderlo. Por favor.
Thanks very much for a very interesting presentation. Are you aware of any standardized method for validation? What do you normally, in the case of validation, which method do you have? Is there any common means to validate the satellite data?
Well, in each project, we had different approaches. For example, we have the field visit, we have the control points. In some of the projects, they had LIDAR data, the higher resolution data. We had, let's say, different field samples. So, for example, in my case, I try to detect the aluminum traces in the area, but then I collect a high number of validation points. I went to the field and I check if what I detected from satellite image is coherent with on the ground. So I can assure you that in all cases, you might need some in-field samples for your validation.
Okay, thanks very much.
Por favor. Muchas gracias.
Hello. Well, first of all, thank you for your presentation. And my question goes mostly for the accuracy of the data that you guys have according to the satellites and, of course, the on-ground samples. How do you guys interpret all the data to get an accuracy of the minerals that you could find in those places?
Of course, all with the in-field samples. Or going, as I mentioned, to higher resolution images. I don't know, maybe some other methods that I'm not aware of that, but we mostly did with in-field samples. We had samples, as you could see in almost all of our projects. We had the chemistry properties of samples. So for example, in the case that I created the concentration maps, then I had some validation samples and I did the comparison between what I was predicted and what the real samples are showing. Of course, the results are quite coherent. We did almost all of us in our projects, but yes, this is what we did. And you know, the main target actually was to see if there is the possibility of using this Copernicus data in different applications. So, you know, maybe this was tricky, but we didn't go completely blind to see, okay, does really this work? We wanted to check. So in many cases, according to extra data we had, like the concentration, the samples, the geological maps, and so on, we tried to, let's say, check if really Copernicus data in these applications can help us, they can improve, let's say, the results of our work or not. And this was, let's say, the big advantage. So maybe we can say that some of these case studies can be just an approval that yes, it can be used. And now you can maybe test it with the new applications in new fields and then see then how much will be precise. But yes, mining is always risky.
Thank you very much.
Tenemos una pregunta desde Zoom.
Un momento, una pregunta del panel, por favor.
¿Puedo?
Sí. Adelante, Florencia.
Buenas tardes. ¿Puedo hacer las preguntas que están en el chat?
Por favor.
Sí. Hola, ¿qué tal? Buenos días a todos. Buenos días, Sara. Un placer. Tengo un comentario que es el siguiente. Dice, también se puede conseguir un modelo con Maxent, con las coordenadas en .csv clasificadas con el algoritmo J48 en Weka. Antes de componerlas sobre las capas raster transformadas en el formato ASCII y coordenadas en CSV que exige Manset. Antes de componerla sobre las capas raster transformadas en el formato ASCII y coordenadas en CSV que exige Manset. Eso es un comentario segundo. Es un comentario. Era un comentario. La segunda. Luciano parece. El otro comentario es, ¿qué software utilizaron para el mapeo de los datos?
This one I understood. The second one is we mainly try to use a Snap, but when we go on, I can say for the developments of our algorithm, each of us, we did the programming. Like me and Elsie, we used R. Luis, Ignacio, I think they use Python. Also Mehdi, I think he used Python. So we use each of us, we use different softwares. I use also Isatis from Jovariances, you might know it. So yes, most of the time the algorithms were developed in programming languages, but let's say the easier steps, they were all in SNAP, which is open access software by ESA, the European Space Agency, which is available for all. And the first question, could someone please translate? Okay. Oh, okay.
¿Otra pregunta, Florencio?
Ella, si quiere, le puedo leer en inglés la pregunta.
Por favor.
Okay, so Sarah, somebody says that maybe the model can be run through Maxent with the coordinates in CSV classified according to the algorithm J48 in Weka. Before composing it, so over the raster layers transform through the format ASCII and CSV coordinates that are required by Maxent.
Okay.
That was a comment.
Okay, thank you.
Ok, vamos a la pregunta en el salón, por favor, entonces.
Thank you so much, Sarah, for your presentation. I have two questions. Maybe I are too basic for you. For me, it's new. I would like to know, like, if the maps that you show are in 2 dimensions, or you also can do it in 3 dimensions in order to detect not only qualitative but also quantitative element analysis. And the other one is there, or if there is any technique that it's possible to use in order to evaluate some dust or gases movements close to the surface in order to evaluate maybe if they can cause any breathing illness or close by the mining industry.
Mm-hmm. Okay, thank you for your, okay, I cannot show, no problem. Thanks for your questions. The first question, of course, the Copernicus data can be used only for superficial because they cover superficial, so the surface, actually. So some of our works, like the acid mine drainage detection or the like the LC's projects, which was detecting the illegal mining, they were all 2-dimensional and on the surface. But for example, as I mentioned, like since we had, for example, in one of the projects, the boreholes, and we had the spectra of the boreholes, we could use it, and after that predicted for the surface. Or in my work, for example, I could create the small layers because I was monitoring the stockpiles and how materials are piling. So in my case, I could somehow go to 3-dimensional, but how I did is that I created these maps, of course, for just surface, which are representative of the surface. And that surface is representative of around 5 meters of materials which are piled by trucks. So I used like 5 months or 3 months, actually. So 3 months, they were covering 1 layer of the stockpiles. So this 1 layer that I created the map was the surface, but it was representative of around half meter or 1 meter. And again, 3 months afterwards, another layer, which we can see from the surface, but it is representative of half meter. So with this method, I could create the volume of the stockpiles with their concentration properties. But as you can see, this is a specific case study. So always it depends what is your application and how you can adopt your method and your data within your application. But of course, unfortunately, this data can show only the properties of the surface. So this is the first question. And the second one, sorry, what was that?
Was about if you know any technique to evaluate dust or gases close by the surface.
Okay, with the dust, I'm not sure. I think Elsie did something in her project, and it depends to let's say the concentration properties of your dust. For example, if you are like, for example, my work, when I was working on bauxite mine, so around it there is the dust dispersion of aluminum. So what you can use, of course, is exactly like detecting a mineral aluminum. So you can use your technique and band ratio of detecting aluminum, and it shows how much this dust is spread, because you can detect it on the surface and you can somehow arrive to the boundary where this dust still is continuing or is stopped. So it depends, yes, to the materials of your case study, but it's always good, in my opinion, that you know your area and you find some indexes or some minerals, something that can highlight what you need. For example, I was searching for titanium and vanadium, but they have a very low value, so we cannot detect them by Copernicus data. But there is a correlation between titanium and vanadium and iron. So I find iron and I arrive automatically to titanium and vanadium. So these are these tricks that with the study in your application, you can arrive to it.
Thank you.
Ok, damos un gran aplauso a Sara María por su presentación.
Thank you very much. Sorry, I have a lot of things here.
Adelante. Ok, vamos a dar entonces inicio desde este momento al panel titulado Imágenes Sentinel para monitorear la actividad minera. Para eso vamos a presentar al primer panelista, que es don Felipe Lobo, desde Brasil. Es profesor adjunto de la Universidad Federal de Sao Paulo y coordinador del curso de Ingeniería del Agua en la CDT, biólogo, máster en teledetección en el Instituto Nacional de Investigaciones Espaciales y doctor en Geografía por la Universidad de Victoria de Canadá, donde desarrolló herramientas para el monitoreo de la calidad del agua y los impactos de la minería. Tenemos 20 minutos de presentación, 15 minutos de pregunta. Adelante, Felipe, por favor.
Gracias. Gracias. Buenas tardes a todos. ¿Me oyen bien? Gracias. Entonces, ok, está bien. Primeiramente, queria agradecer a todos o convite, especialmente a JNCC for the invite. E eu vou falar em inglês porque é mais simples para mim. So, first of all, thank you so much for the invitation. I would like to thank Matt Smith for the invitation. I'd like to thank you, Universidade Católica del Norte for receive us and promote this event, very important. I'd like to thank you all for listening and watching our event here, for you that in this room and for the other ones watching us on live. And it's my honor to be here to present some really interesting information. And I'm glad that Sarah gave us a really good introduction of how we can use Copernicus data, especially Sentinel family data, for mining applications. So I'd like to start my, it changed automatically. So my name is Felipe Lobo. I'm from University of Pelotas in Brazil, the south of Brazil. Today I'm gonna show you some data, some information about work that we've been done in the last few years, especially looking at mapping mining areas in Brazilian Amazon. So that's a very hot topic that it's calls and calling people's attention, not only from Brazil and the whole world, because of different aspects of the mining in Brazil. So Brazil is one of the leading countries in mineral production. Most of it, 40%, comes from the Amazon. And as you know, there is a large financial compensation. There's a lot of royalties coming from mining in Brazil, which is one of our main sources of money in Brazil. But also, we've got a lot of intense social conflicts and environmental impacts due to mining. And the work we have done and we'll be doing is to shed some light on the mining activities in Brazil. So we'd like to present for you different aspects of mining in this region. First of all, in Brazil, we've got basically two main types of mining. First one is industrial mining, which you are more used to here in Antofagasta, is basically industrial mining, very organized way to mine. Here's an example of Carajás in the state of Pará, this iron and copper mining in nickel. Although we have also small-scale gold mining. Sarah showed us a little of mapping small-scale in Colombia. And here in Brazil, we've got to Peru, many countries in Latin America and also Asia, Africa are facing issues with small-scale mining in their territories. What happened is most of this mining are illegal. So there's no much control over the impacts and the social aspects of it. And then it causes several impacts, and we have social conflict with indigenous people and locals and the government. So it's a very complex issue, and that's why we're trying to get some information so we can explain and try to understand what's happening, and also try to make a difference what is industrial, what is small scale activity. So because they are totally different for the region. For example, in the north of Roraima state, we have indigenous land called Yanomami, and then it's mostly illegal activities there. So we're not supposed to have any mining in indigenous land, but we can find several airstrips and mining activities happening there. That's an example. So as I told you, although a lot of mining produce, there's importance of economy for the Amazon, not much is known about this attribute of where are the mining, what kind of types, what kind of ores or minerals we are looking at. So that's our goal today, to show you and explain a little bit more. Sarah also explained a little bit how difficult it is to map mining activity, especially small scale, because of the highly spectral variability of the land, and also because they're very small. So we need high resolution data to detect exactly where are these mining activities. So that's why I'm showing you today a very simple and rapid and quick, accurate method to classify small scale and industrial mining in the Amazon. For that, we use the Sentinel-2 data, which gives us a 10-meter spatial resolution, which is very useful for this kind of work, because as I said, we need a high spatial data to detect these mining activities. So, oops. Come back. So our objective, first of all, is to actually map the current mining activities in Brazil, especially in the Amazon. So we use Sentinel-2 images, and we apply that on a Google Earth Engine platform. I don't know if you are familiar with that, but we are, especially in our group, you're using Google Earth Engine a lot because it's very easy to access the satellite collection. And then after mapping the area, you would like to give attributes, to find attributes in terms of license status, is legal or illegal, what kind of mineral they exploit, amongst other information. So we go further on the mapping activity. So we identified the 13 main areas for mining in the Amazon, including industrial and small scale. So for example, we have Carajás here, which produce ferro, iron, and copper. Also in Tapajós, a very known area for small scale gold mining. We have aluminum and different activities. So we first identify where the main areas, and then we look specifically to these areas to detect mining activity. So we use basically 38 Sentinel-2 images from these regions to detect these mining areas. Basically, the classification we did was following this method here. We access the image on the Google Earth Engine, and then we choose cloud-free image from, in this case, in 2017, we use this 2017 images. We train the classification method. We use the CART, the supervised classification method, as a tree decision method. So we do the supervised classification, actually indicating where the mining, where's the water, where's the forest. We did that on Google Earth Engine. For validation, as Sarah mentioned, again, sorry, using a lot of your presentation, how important is the validation to see the accuracy of these maps? For that, we use the rapid eye images. So it's a commercial satellites with very high resolution, which was available for the Brazilian government. So the Brazilian government bought the bunch of images for the whole country. So we had access to these commercial images from rapid eye. We uploaded this image into the Google Earth Engine and did the same classification for validation purposes. So here an example, we identify an image mining area, and then we do a supervised classification, which includes water as well, because we see in the last presentation that small ponds due to mine activity or these tailings are very often present in these areas. We include this type of ponds as well. And within the ArcGIS, we did a little of editing and make sure that all the areas are correctly mapped. And also the validation purpose using rapid eye images. And once we mapped the whole areas, we crossed this information with the Department of National Production, Mineral Production in Brazil. So they give us, it is available online, but basically can intersect with polygons provided by DNPM to identify what kind of mineral, when it was given this license, who is also in the name of the person. There's a lot of information that we used as well. Oh, sorry. Here's an example of a mining area, small scale mining area. We have different land covers. So based on the spectral differences between them, we were able to detect using the supervised classification. And an example of these polygons here are given by the Federal Mineral Production and gives us this information such as what kind of ore or mineral, is it like tin? In the name, when, is it active or not? Where is located? And the results after we mapped all these 13 areas, we are looking in this to see between rapid eye Sentinel-2 if there are some coherences, if they are matching. And for Carajás region, for example, which is industrial for iron mainly, we had a good agreement between the two data for the rapid eye, which is a very high resolution, about 1 meter, and Sentinel-2 resolution of 10 meters. Although there are some difference in dates, the kappa index, which gives the information how the agreement between the two classifications was better for industrial area than for small scale gold areas such as this one, because there's very small areas and distributed not regularly, so it's very hard to kind of detect exactly where are this mining. Also, it changes over time much faster than industrial areas, because the groups they move along the rivers and it's hard to track them. An example here for Trombetas region is industrial area for aluminum production. Also much easier to map because it's very large and concentrated in one area. In another region for Peixoto de Azevedo in Mato Grosso state, we have the same issue of small scale gold mining, which is basically these white areas. And also the mosaic of land use, different land use. So there are farms and crops. It's really complex. But basically we were able to map these areas, and it's very interesting. For validation, which is very important, right? Because to make sure that our data is confident, you can trust on this data, we used, for validation, we mapped 200 square kilometers just for validation. And then overall accuracy of 98%, a kappa index of 7.7. After all this mapping all the mining, we found more than 1,000 square kilometers within these regions, which is very surprising because it's a large number, and also because there's no information before this work. So we didn't know exactly how much. So now we're having a better idea what's the area and in this region. Mostly of these mining areas, we can see here for different types of minerals, mostly for gold in the state of Pará, mostly here in blue. Here colors in states of the states and the minerals on the bottom. And Stanley team as well, they use a lot, some small scale activities, so you can see some values there. When you look into specifically into the states, Pará state is the one there's more mining activities, especially for gold, bauxite, and other minerals. Here you can see, for example, that in small scale, Rio Tapajós, for example, in Pará, they've got more than 345 square kilometers of small scale gold mining. well, it's a lot. It's basically one third of mining areas in the whole country, in the whole region. And that it was a really interesting information to start like grasping on what kind of activities and the consequences of that in the region. After we map these regions, we want to look like some economic aspects of it. So how much of benefits these different types of mining provide to the country, or the opposite? How many or only impacts we've got from some mining instead of bringing resources to the country? So we look a little bit of linking this economic and spatial data for this study. So we kept like working on this data. Sorry. So we want to look at we did the mining map, and when you want to look by taking information of how much the states they declare how much they make money with the mining, and then we did this cross validate this cross between the mining areas and the benefit, like the royalties they pay for each of these ores. So for example, in terms of area, gold is the leading one, mostly because of the small scale activities. And when it comes to the royalties, iron, which is basically from the Vale, the main company, the mining company in Brazil, it gives it comprises a small area comparing to the amount of royalties it brings. So the idea is to differentiate a little bit of small scale and industrial area, so people understand a bit what mining is in the Amazon. So when you look at the rate of how much royalty you provide per area, so iron gives the highest rate for the royalties in dollars, $1 million per square kilometer, whereas gold is on the bottom of the lists because it's a huge area and not much benefit from it. And I would like to bring the last information of this presentation is about mining, mapping mining dredges. Dredges are, I will show what it is, but basically they are inside the rivers. Within the rivers, dredging the bottom of the rivers and trying to get the gold that is being deposited over the years on the bottom of the rivers. So basically in two main rivers, Tapajós River, this one, and Madeira River, different types of water, but they show, we can, oh, sorry. Yeah. So that's a kind of a dredge within the river, okay? And that's a couple one, and that's hundreds of dredges in the river, in the same river, in the case of Madeira River. They're all illegal, and there's a problem. Where are they? How we can control that? So we'd like to show some techniques how to track them. And it's only possible because of the images by Sentinel-2 gives a 10-meter resolution. So we are able to detect a group of dredges within the river. And again, we use the Google Earth engine to access quickly because the Google Earth engine can access very quickly any image from, you don't need to download them, right? And then we compare with the Google Earth Pro, which sometimes is very high resolution, just to check if you what's seen the Sentinel-2 images from the same day, you actually see on Google Earth Pro because you can see them here. And doing that over time, oh, sorry. For Tapajós River, it's Águas Claras. You can see here balsas with the dredge ones. The flux of the flow of the river is over there. And all this sediment plume derived from dredges, you can track them as well. Here's in the Madeira River. For Madeira River, which is a very muddy water, you can't see the track of the sediment, the sediment plume caused by the dredges, because the water is already muddy. Differently from the Tapajós River with a clear water, you can see that. So after mapping dredges over 4 years in these two rivers, we found in Rio Madeira River, approximately 300 dredges along the river. And then we did a kind of a heat map to see where they're located. And for Tapajós River, there's less. There's approximately 15 dredges along the river. They are basically larger than the other ones, but not as much as in Madeira River. And the last one I'd like to show you, we tracked one of the dredges over time. See how much time they spend on the situ. They move. So we did some of these experiments or to track these dredges, and usually take like 2 months. They stay on the same site for 2 months, sometimes changing places, and shows how they are prepared to stay 2 months in this area. So there's a lot of, it's not artisanal gold mining as people used to say, because they have a very good infrastructure to keep them with the food and water, so it's not so isolated, right? And yeah, that's it. I thank you so much for your time and your attention. And I am open to have a discussion and ask and answer some questions. Thank you.
Perfecto, pasamos entonces a la etapa de las preguntas, por favor. Preguntas en el salón. Si hay preguntas en el chat también, por favor. Ahí, por favor, el micrófono.
So, hello, thank you for your presentation. And my question goes to mostly to the dredges. Of course, they're illegal and they are making illegal mining, and of course the dust they produce can contaminate the river also. So this kind of mining can be really damaging to the ecosystem of the river. So what could be the solution to this problem? Mostly.
What's your name, sorry?
Francisco.
Francisco.
Mm-hmm.
Thank you, Francisco. That's a very good question. That's the reason why we are mapping them, because before we did that, there's no information where are they. And to answer your question, what kind of impacts and to extend this impact goal, we need to first track where are they, and of course after that I think there's need some research, especially in situ, go there, which is very complicated to go to these areas and kind of measure, take water sample to see the amount of concentration of heavy metals or even sediments suspended in water. For example, Tapajós River, because there's so much gold mining and mining sediment plume caused by mining, either dredges or in land, that they are changing the color of the river. It's usually transparent. It's called a clear water. It's becoming muddy water by basically only mining activities. So it's huge impact. So it causes impact on fish community, which of course impacts the human community that live there, and they mostly eat fish and use the river for everything, water supply. So that's the first step. And I hope that it causes some impact on policymakers and decision makers to see that we need to kind of progress on monitoring these events. Thank you, Francisco.
Thank you so much.
Y el Marc, por favor. Acá, por favor.
Obrigado for the presentation. It was excellent. My question is somewhat related to Francisco's question in terms of the long-term impact. Have you, or are you planning to look at the sites that you've identified and see what level of regeneration post natural regeneration, like does the forest grow back post these types of activities?
Yeah, that's a good question, Matt. Because this topic is very complex and these areas are so remote, we need a lot of funding to for projects to actually go and measure and trying to keep the research going. To be honest, lately I haven't been able to kind of keep that monitoring system because of fundings and stuff, and also because of the difficulty to go to these places and validate any kind of algorithm or method we apply. So to be honest with you, I think we are very slow on that, and hopefully that the work we've done brings the attention and rise the needs to keep that going. But yeah, it's a long-term process for sure.
Yeah, if I may, just a quick follow-up question. I mean, my role in JNCC is very much around taking this type of information and giving it into the hands of decision makers to, make the right decision on behalf of all of society that they're representing, really. And I was just wondering, when you've taken this to representatives, how do they react to the information, and how do you convey that information to them, and how much trust is there in this type of data and information for supporting decision making?
That's a good question, man, because usually the technical group or technical personnel that is within the government, or they are very keen to use it. But then when it comes to take this information, not only as my work, but in the Amazon in general, as a policy, usually you have some resistance, because it changes somehow the status quo. It changes how things are produced in the country. So, but once these information are so clear that you can't deny, right? There's a lot of information that it needs to be integrated in policymakers. I've been to IBAMA, which is the EPA in Brazil. They are interested. We kind of almost did a project together so they can use these methods, but it didn't go, didn't succeed. But yeah, but that's, I think, the main process is to convince policymakers to use this information, because we, as technical professionals, we know that there are some uncertainties, but overall it's really good, and it's trustful information. And then I'm with you. I'm on this process to convince policymakers, to convince institutes to use more and more Copernicus data, satellite images for monitoring and also to develop the country as well, right? The land and everything. So that's the idea. Thank you.
Bien. Florencio, ¿alguna pregunta o comentario por el chat?
No question from the chat.
Ok. Ok. ¿Dónde? Ahí, por favor.
No, Italo. No question from the chat.
Gracias.
Here. Thank you very much, Felipe, for your presentation. I was just wondering, I don't use satellite images for mine my topic is water. So I was wondering if you had to do any kind of different treatment or correction to the images by working on the Amazon. So this is what I have in mind, right? So here our mining is mostly located in a desert. So we have very clear skies. We don't have huge water bodies, or we don't have that much evaporation happening. So was it difficult to work with that, and how did you really process it? Because in my case, when I want to separate one from the other, I just use some simple vegetable indexes and right, like water, etc. But how did you do it not to mix what was happening in this area that is very humid? It's full of water.
What's your name, sorry?
Damare.
Damani. Obrigado. Thank you. That's a technical issue that we remote sensors people usually have, right? What kind of classification we going to use? As I said, I use the supervised classification. So I trained the areas as, okay, this mining, this is water, this, and but it's not it's not perfect, and that's why we did a after mapping this editing to kind of look at quality control. So there's this next step of quality control to make sure that you're not classifying different uses as mining. In this case as well, we combined the mining pits with the water or the ponds that they are left, because we understand that they all mining areas as well, although it's water, but it's still due to mining. So in this case, we combine these two. That's
but then in all the points where you have mining, you knew that they were mining points, or you had some automated process at some point?
Sorry, I couldn't understand one.
My mask a little bit. I will have it first. So in every place that you located mining, you knew that there was mining there, or at some point? Okay.
Yeah,
always.
we did a research before to say where are the main areas.
Okay. Yeah.
Because of course there's more mining in different areas, but we focus on the main ones.
You work with the ones that you knew that they were mining.
Yeah,
okay.
we knew.
Yeah.
We identified and said, let's go in Carajás area and map everything there.
Okay, thanks.
Thank you.
Muy bien. Agradeciendo a Sara, Felipe.
Gracias.
Las dos ponencias tan importantes que tienen que ver con la caracterización de nuestra Tierra, una mirada a la Tierra desde los satélites. Vamos a pasar a un break, un coffee break, para regresar a las dos últimas presentaciones y al conversatorio en conjunto. ¿Les parece? Muchas gracias.
Gracias,
Felipe, un
muchas
aplauso.
gracias. Gracias.
Hay gente que dice, bueno, pero yo antes que se comunica soy viendo entre comillas, soy funcionario del gobierno, tengo lealtad primero con el representante con el partido. Entonces, de alguna manera podría tener sentido, ser plausible, llegar a la realidad en el sentido de, bueno, vamos a ver si el partido conquistador aquí en la real. Una teoría mía, una teoría que está ahí. Compromiso con esta agenda compleja de orden público y seguridad, ¿no? Yo lo también, que también me parece que es una apuesta que está haciendo el presidente. Ahora, también me pregunto por otro lado, sí, empieza como a hacer una figura controvertida, porque existo el condicionamiento de haber dicho cosas en contra de carabineros, etcétera, pone en algún sentido un riesgo para los consensos que se tienen que alcanzar. Aquí muchos han hablado de que en el fondo en la tarde se va a tener una reunión con los partidos de oposición para buscar consenso, para buscar el diálogo, pero no sé si se le pidió explícitamente al presidente algún tipo de garantía. Si se le llega a pedir a un presidente que su gabinete tenga este u otro énfasis, porque si solo se trata de la interlocución con el Parlamento, podría solo cambiar a suministraciones. Y aquí vemos que es un ajuste mayor, tocando incluso una subsecretaría, que yo creo que esto no estaba en la cabeza de muchos, finalmente. ¿Podría eso condicionar el diálogo? Bueno, no se dijo explícitamente, pero sí se señaló implícitamente. Recordemos que la oposición no fue a la moneda y el lunes era originalmente el día en que había sido convocado para discutir sobre este nuevo proceso constituyente. ¿Preparados? Vamos a continuar entonces con esta segunda parte. Nos va a corresponder dos presentaciones más, la de Jaime Ortega y Taras Metzeljab. Quiero dejar con ustedes a don Ítalo Montapré, director de la Escuela de Negocios Mineros.
Bueno, vamos a recomenzar. Recordarle que estamos en el panel de imágenes Sentinel para monitorear la actividad minera, y es por ello que ahora vamos a dejar al panelista, señor Jaime Ortega, quien es licenciado y magíster en matemáticas de la Universidad de Concepción y doctor en ciencias matemáticas de la Universidad Complutense de Madrid. Es profesor titular del Departamento de Ingeniería Matemáticas e investigador principal del Centro de Modelamiento Matemático de la Universidad de Chile, con más de 20 años en proyectos de ingeniería y desarrollo, innovación y desarrollo en minería y aplicaciones de procesamiento de imágenes y diseño óptico. Fue director del Laboratorio de Imágenes del Centro de Modelamiento Matemático y es investigador principal y director del proyecto P6, Sensorización y Monitoreo Remoto de Acuíferos, del Centro de Tecnología para el Agua, CAPTA. Actualmente es investigador principal y encargado del área de minería digital del Centro de Modelamiento Matemático. Además es coordinador del proyecto Copernicus de la Universidad de Chile en el CMM. Proyecto que desarrolla el repositorio de los datos satelitales provistos por el programa Copernicus de la Unión Europea y codirector del grupo de imágenes satelitales. Vamos a dejar a don Jaime con su ponencia Monitoreo remoto de relaves mineros. Por favor.
Primero que nada, voy a hablar en castellano. Quiero agradecer nuevamente a la Universidad Católica del Norte por la realización de este evento acá, y JNCC y a todos los invitados por estar aquí. Voy a contar brevemente parte de su...
Already.
Ok, ahí mejor. Ok, muchas gracias. Voy a hablar sobre un tema que llevamos varios años ya trabajando en conjunto con colegas de la Mining Technology Center, en particular Cristian Ile, que está aquí presente, sobre los relaves en Chile. Voy a contar brevemente qué es lo que es el programa Copernicus. Ya sé que varias personas ya han comentado esto, pero básicamente es un programa satelital que está monitoreando toda la Tierra, ¿verdad?, con una serie de satélites distintos. Por favor, la siguiente. ¿Ya? Principalmente, dado que vamos a hablar de temas de minería, me voy a enfocar principalmente en dos satélites, como comentó también Sara, que son el Sentinel-1 y el Sentinel-2, que en realidad no son dos satélites, en realidad son varios satélites, porque teníamos Sentinel-1A y Sentinel-1B, estaban girando hacia la Tierra, y la gracia de Sentinel-1 es que es el primer satélite de radar que entrega información gratuita, ¿ya?, para todo el mundo, Con un monitoreo constante, uno sabe que cada 6 o 12 días, dependiendo de dónde esté, uno va a tener una nueva imagen para monitorear, ¿ya? Son satélites de radar de banda C, que tiene una resolución entre 9 y 40 metros, dependiendo un poquito de la banda, ¿ya? Este tipo de satélites lo que permiten es medir deformaciones de la Tierra. Eso es una gran cosa. Y por supuesto también lo que usamos es el Sentinel-2. El Sentinel-2 son satélites multiespectrales, o sea, toman fotos, lo que uno conoce como fotos satelitales, pero no toma solo una foto, sino que toma una serie de fotos en distintos rangos del espectro electromagnético, ¿ya? En particular, este tiene 13 bandas, o sea, está tomando, entre comillas, como dijéramos, como 13 fotos en distintas bandas del espectro electromagnético, y esto permite generar una serie de aplicaciones y visualizar distintas cosas, ¿ya? Nuevamente, Sentinel-2 son dos, Sentinel-2A y Sentinel-2B. Lamentablemente, hace poco el Sentinel-1B dejó de funcionar, pero gracias, por suerte, la Unión Europea ya está preparando la 6D. Por favor, la siguiente, ¿ya? Aquí hay un poco un mapa de los satélites que hay, tal como comentaron al comienzo, son una constelación donde hay química atmosférica, hay para monitorear océanos y una serie de ellos, y podemos ver que algunos ya se lanzaron, están en órbita, ¿verdad? Hace poco dejó de funcionar, pero la Unión Europea ya está planeando y ya tiene planificado el lanzamiento de las nuevas series de satélites, lo cual le va a dar continuidad a este programa. Esto significa que en general tenemos imágenes desde el 2016 en adelante, en forma periódica, y tenemos certeza de que por lo menos hasta el 2030 o más vamos a seguir teniendo imágenes, lo cual da la opción de que uno plantee temas de monitoreo constante en distintas aplicaciones. La siguiente, por favor. Bueno, bien rápido, ¿qué es lo que miden estos satélites? La siguiente, por favor. Los satélites, bueno, uno tiene el espectro electromagnético, en los cuales tiene diferentes tipos de onda, algunas que las ve, otras que no las ve, existe el rango visible, ultravioleta, microondas y una serie de eso, ¿ya? Lo que hacen los satélites es tomar algunas partes de este espectro electromagnético y tomar imágenes en ese rango, ¿ya? Por favor, la siguiente, ¿ya? ¿Por qué? Porque cada mineral o cada material que uno tiene, cuando viene la luz del sol y refleja en ella, tiene una especie de firma espectral, o sea, el espectro electromagnético se manifiesta de una manera distinta. Y uno podría decir, en el fondo, de que cada mineral o cada material tiene una especie de huella de identidad que permite que uno distinga un material de otro cuando ve el espectro electromagnético. Y esto es lo que se conocen como firmas espectrales, y es lo que permite que podamos distinguir qué es lo que es un árbol, qué es lo que es el agua, qué es lo que es la tierra, qué es lo que es el cemento, o qué es lo que es una casa, la construcción de una casa, ¿ya? La siguiente, por favor. Entonces, uno puede ver distintos tipos de satélites y todos los satélites ven distintas partes de este espectro electromagnético. Hay algunos que se llaman hiperespectrales, que van un rango muchísimo más grande, ¿ya? Pero claro, entre más bandas es más caro, ¿ya? Y no siempre están en un cierto rango de bandas porque cuando se construyó se pensó en cierto tipo de aplicación y por lo tanto los sensores están hechos para distinguir ese tipo de rango. Dependiendo un poquito de la aplicación, uno va definiendo los tipos de rango. Ya, la siguiente, por favor. Por otro lado, los satélites de radar usan una técnica que se llama la interferometría. ¿Y qué es lo que es eso? Bueno, lo que cuando uno va en un auto y viene la policía y le dispara al radar, ¿verdad? Lo que le hace a uno es medir la velocidad, ¿verdad? Porque en el fondo lanza dos pulsos y ve la diferencia de esos pulsos, ¿ya? Como soy matemático, uno dice, tengo una exponencial compleja y estoy midiendo el ángulo de esa exponencial, que es lo que se conoce como la fase. Y la diferencia de esa señal tiene que ver con una diferencia en deformación, ¿ya? Y eso es lo que hacen estos satélites, que permiten distinguir deformaciones, pero no deformaciones rápidas, deformaciones muy lentas, ¿ya? Estamos hablando de cosas que se deforman centímetros por año, ¿ya? Pero bueno, eso es muy bueno, ¿ya? Por favor, la siguiente, ¿ya? Por ejemplo, esta es una de formación acumulada de un cierto sector, ¿ya? Esto es un salar en el norte, y los colores lo que me van reflejando es cuánto se ha deformado la tierra, la subsidencia del levantamiento, y lo que muestra es cuánto se ha deformado en un cierto periodo de tiempo, ¿verdad? Y uno puede decir, bueno, esto se ha deformado a una velocidad de 6 centímetros por año o 10 centímetros por año, se está hundiendo, se está levantando, y es una información muy valiosa, ya sea para aplicaciones en volcanes y una serie de aplicaciones de las cuales Taras nos va a contar un montón de ellas después, ¿verdad? Bueno, siguiente, por favor, ¿ya? Estamos en minería, ¿ya? La minería en Chile, y está en la discusión siempre, la minería, hay que ir hacia una mejor minería, ¿ya? No, la minería y la ecología siempre están medias peleadas, ¿verdad? Y eso es una cosa. Por favor, la siguiente, ¿verdad? ¿Qué es lo que la gente habla? La gente, y más de ustedes le han dicho, vamos a hablar de la minería 4.0, ¿verdad? Un discurso. Pero ¿qué es lo que debería hacer la minería 4.0? Bueno, primero, una minería que tenga un mayor nivel tecnológico, ¿verdad? Donde saquemos a las personas de las operaciones y están entrando los camiones teleoperados, las palas teleoperadas, ¿verdad? Y una serie de cosas de ese tipo, ¿verdad? También hay un aumento en la productividad, y ese aumento en la productividad es porque cada día hay una mayor demanda de los minerales, ¿verdad? Como dicen, hay más teléfonos, hay más equipos, hay más autos, los autos necesitan más cobre. Chile, principalmente, cuando uno habla de la minería de cobre, quizás vamos a empezar a hablar más del litio después, ¿verdad? Pero cada vez se requieren más materiales, más cobre en particular, ¿verdad? Por lo tanto, hay un tremendo desafío en las empresas mineras de cómo aumento mi productividad, ¿verdad? Pero por otro lado, tengo que ese aumento de productividad no tenga un impacto en el medio ambiente, ni tampoco en las comunidades que están cerca. Tenemos la historia de Barrick, ¿verdad? Que tuvo que cerrar porque no hubo un acuerdo con las comunidades, básicamente, y esa mina tuvo que cerrar, ¿verdad? Por lo tanto, necesitamos eso. Y, como decía, tenemos que ir hacia las operaciones remotas. Todos dicen, no, mire, yo aquí en Spence estamos tratando de ver, y empiezan con los distintos ejemplos de minas que están operadas. Siguiente, por favor. Bien, en particular, un tema no menor en Chile son los relaves, ¿ya? Chile es el tercer país del mundo con más relaves. Solo China y Estados Unidos nos superan en número de relaves, ¿ya? Tenemos alrededor de un poco más de 800 relaves en Chile, pero de esos 800 son 100 y poco los que están en minas activas, pero tenemos una gran cantidad que están en minas que son inactivas o los abandonados, ¿verdad? Y eso están olvidados. Esa es la plaza donde los niños juegan a la pelota en el barrio de Nandacoyo, ¿verdad? La placita en Copiapó, ¿verdad? Y por lo tanto, hay una tremenda pregunta de cómo yo puedo estar vigilando los depósitos de relave, y no solo los activos. En general, los activos, las grandes compañías mineras invierten dinero en poner sensores, ponen inclinómetros, ponen piezómetros, y están monitoreando eso. La pregunta es qué pasa con los que no están monitoreando. ¿Verdad? Y en ese sentido, las imágenes satelitales, y en particular Copernicus, que son imágenes gratuitas, ofrecen una tremenda posibilidad de hacer vigilancia, ¿verdad? La pregunta es, yo tengo un relave que está inactivo hace 20 años, uno lo ve que está medio seco arriba, ¿verdad? Parece tierra seca. Uno puede jugar a la pelota un partido arriba, ¿verdad? La pregunta es que si viene una lluvia que cae en 100 milímetros de agua en un día, ¿qué sucede? ¿No? Los eventos extremos están cada día sucediendo más. Y por lo tanto hay una tremenda pregunta y un tremendo desafío en preocuparnos no solo de los activos que son de las grandes compañías, sino también qué pasa con el resto, ¿no? No sé si ustedes conocen el Cerro Santa Lucía, que está en Santiago, ¿verdad? Según estimaciones, ahora en cada 30 horas aproximadamente se produce relave del tamaño de un Cerro Santa Lucía, y en pocos años más, en menos de un día, vamos a tener un Cerro Santa Lucía de relave. O sea, es un problema grande. ¿Ya? La siguiente, por favor, ¿verdad? Entonces, ¿cuál es el tipo de problemas que uno se pregunta? Normalmente hay dos preguntas que dicen, yo quiero estabilidad física y estabilidad química, ¿verdad? Estabilidad física, no quiero que se me venga bajo el muro, ¿verdad? porque la pata empezó a moverse o cosas por el estilo, pero tampoco quiero que tenga percolación, ¿verdad? Que aparezca un fluido de agua que está dentro del relave y empieza a percolar hacia otros lados, ¿verdad? Y por lo tanto las imágenes satelitales, uno puede empezar a combinar de alguna manera para ir midiendo este tipo de cosas. Por ejemplo, este es un relave, creo que este es Piuquenes, y uno puede ver el muro que está aquí, ¿verdad? Y a uno le gustaría saber si este muro se está moviendo, ¿verdad? Entonces la interferometría satelital me permite ir estudiando qué pasa con la deformación de ese muro. Si ese muro se está asentando, lo cual es natural, pero lo que esperaría es que fuera un asentamiento no explosivo, que tuviera un tiempo. Pero también me interesa, y esto quizás les parece conocido, este es el depósito de relave de nuestros amigos de La Escondida, que están aquí cerca, ¿verdad? Donde aquí está el muro, aquí está la cubeta, y a mí me interesa que este cúmulo de agua no se me vaya a acercar al muro. Y tengo que estar monitoreando que esta laguna no llegue al muro, porque si llega al muro, el muro se me puede ir abajo, ¿verdad? Entonces las imágenes satelitales, tanto ópticas como las de radar, nos permiten ir obteniendo mediciones de este tipo, ¿ya? Y nos permiten no solo eso, sino que también uno podría decir, ¿y cuándo es un comportamiento normal? Bueno, ahí usamos, yo soy matemático, ¿verdad? Y uno dice, ahí usamos la matemática, la inteligencia de datos, usamos la computación de alto desempeño, y eso nos permite crear indicadores, KPI, para que estas cosas se puedan mejorar. La siguiente, por favor. ¿Qué es lo que queremos evitar? Queremos evitar el desastre San Marcos, ¿verdad? Matt vive en Brasil, Felipe también, y recuerdan el desastre de San Marcos, donde se vino abajo un muro de un depósito relave, y lo que pasa con ese muro es que hay una gran cantidad de lodo que baña todo, pero este lodo que cubrió todo este sector, aquí hay gente que murió, pero también todo este sector de tierra queda totalmente contaminado. Y no es fácil descontaminarlo, ¿verdad? La siguiente, por favor. Y tenemos un desastre más cercano. En enero del 2019, el famoso desastre de Brumadinho fue un muro de un depósito relave, se vino abajo y destruyó completamente toda una zona, muriendo 400 personas. Muchos de ellos todavía están desaparecidos y no van a aparecer, ¿ya? De hecho, entiendo que los ejecutivos de la minera Vale, que era la que operaba esto, están presos. Hay alguno que creo estaba preso, ¿verdad? La siguiente, por favor. Bueno, esto es para que ustedes piensen, esto es el muro de un relave. Este era el muro de Brumadinho, ¿ya? Y el muro de Brumadinho, este es el instante cero. Después de 0,2 segundos empezó a romperse. Después de 5 segundos ya tenía una fractura grande acá abajo. La siguiente, por favor. Después de 6 segundos, el muro se vino abajo completamente y toda la cubeta, que eran millones de metros cúbicos, se vació en 6 minutos. O sea, el problema aquí no es que yo pueda hacer algo ahí, sino que la idea no es que yo pueda resolver el día antes de esto. La pregunta es cómo yo prevengo esto, cómo yo evito esto, cómo hago una ingeniería de buena manera para evitar este tipo de procesos. Este proceso se llama liquefacción, ¿verdad? ¿Qué sucede? Tengo un muro que es de los tipos de arena que tiene el relave, lo van construyendo con ese mismo tipo de cosas, pero si no está bien hecho y percola la humedad por dentro, esto finalmente termina como un fluido y se viene abajo. Y se viene abajo en pocos minutos, ¿verdad? Entonces, la pregunta es cómo nosotros somos capaces, ¿verdad? Usando ingeniería, usando satélites y usando una serie de herramientas, generar indicadores para que eviten este tipo de cosas. Afortunadamente en Chile no hemos tenido este tipo de desastres. La siguiente, por favor. Bueno, ahí está después de 6 minutos como quedó completamente vaciada la cubeta del relave. ¿Ya? 6 minutos, no hay tiempo de reaccionar. La siguiente, por favor. Bueno, un desafío importante es hacernos cargo, como les decía, de los relaves abandonados. Esta es una foto de Andacollo. Estas son casas. Aquí hay población. Y estos son relaves abandonados. ¿Ya? O sea, los relaves abandonados, en su tiempo, estaban lejos de la población pero ahora son la plaza del barrio, ¿verdad? Y por lo tanto tenemos que hacernos cargo también de ellos, ¿verdad? ¿Qué sucede con ellos? ¿Ya? Y hay muchísimos que son pequeños, ¿verdad? Pero están, sobre todo, si uno ve el catálogo de Cernejiumín, ve que en Andacoyo, Copiapó y muchas de esas ciudades están completamente pobladas de relaves. ¿Ya? La siguiente, por favor. Bueno, ¿qué tipo de cosas nosotros podemos hacer? Bueno, podemos estudiar, por ejemplo, un relave, el relave de ovejería, que es el relave de la mina andina de Codelco, ¿verdad? Y uno puede generar indicadores. La siguiente, por favor. ¿Verdad? ¿Qué tipo de cosas puede ver? Bueno, yo podría ver la deformación, si hay subsidencia o no, o levantamiento en el entorno del relave, pero además me permite analizar toda la zona. Por ejemplo, podría hacer ese tipo de cosas, ¿verdad? La siguiente, por favor. Pero también me permite analizar otro tipo de cosas, por ejemplo, estudiar la corona, ¿verdad? Estudiarme la corona del muro y preguntarme, esta corona, ¿cómo se está deformando? Es natural que se vaya deformando, ¿verdad? Porque se va compactando. Pero la pregunta es, ¿se está compactando en forma natural o no natural? ¿Verdad? Y herramientas como la interferometría, ¿verdad? Me permiten analizar series de tiempo. Notemos aquí, esta serie de tiempo parte como en el 2015 hasta ahora, porque tenemos imágenes satelitales de Sentinel-1 desde esa época y me permite hacer este tipo de análisis, ¿verdad? Y la pregunta es, y ahí viene un poco la pregunta con los geomecánicos y hay que conversar, ¿esa curva es normal o no es normal? ¿Verdad? Bueno, esa no es mi tarea, esa es la tarea de los geomecánicos con los cuales trabajamos, ¿verdad? Pero ese tipo de herramientas son las que uno puede ir generando con este tipo de cosas y bueno, puede ir midiendo una serie de otro tipo de aplicaciones. Este mismo tipo de aplicaciones pueden servir, estamos en otro proyecto, para monitorear los glaciares. Y los glaciares, ¿dónde están los glaciares? ¿Qué está pasando con ellos? ¿Verdad? ¿Qué pasa con los volcanes? ¿Qué pasa con una serie de otras aplicaciones donde aparecen este tipo de cuestiones? Adelante, por favor. Bueno, esto es parte de todo el equipo con el que estamos trabajando en los diferentes proyectos, ¿verdad? Por ahí aparece Florencio, ahí arriba está Cristian, que está sentado ahí atrás, ¿verdad? Y hay muchos estudiantes y gente con la cual estamos trabajando para hacer este tipo de desarrollo. Lo importante es cómo nosotros somos capaces de generar esta herramienta y transferirla a quienes les interese. Porque no son solo las mineras, también está la Superintendencia de Medio Ambiente, también está Cernejiumín, también está la Subsecretaría de Minería, ¿verdad? Y que son los entes que tienen que estar vigilando que las cosas se hagan bien, ¿verdad? Tener una minería verde no significa que vamos a hacer una minería ecológica, ¿verdad? Debemos hacerlo de la mejor manera posible. La siguiente, por favor. Bueno, esto es parte de las empresas e instituciones con las cuales estamos desarrollando parte de estos desarrollos. La siguiente. Listo. Muchas gracias.
Gracias, Jaime. Vamos a dejar las preguntas para después de la presentación de Tara, de tal manera de hacerlas todas en conjunto a la hora de el conversatorio. Como pueden ver, hemos analizado temas muy relevantes desde el punto de vista de lo que es Copernicus, desde el punto de vista de lo que es un conjunto de satélites que están, como les decía, caracterizando la superficie de la Tierra. Gracias. Pero lo interesante es cómo podemos usar estos elementos, este sistema de satélites, para la prevención de riesgos producidos en el entorno de la minería. Dicho aquello, vamos a dejar con nosotros a Taras Marceljuk, de Finlandia. Él es ingeniero de sistemas, experto en la aplicación de inteligencia artificial avanzada en mercados rentables. Durante más de una década, Taras gestionó y supervisó sistemas críticos de los que depende la sociedad. Vive en los Países Bajos con su familia y tiene una formación que abarca la física cuántica, la radioelectrónica y la economía, con títulos científicos reconocidos internacionalmente por la Universidad Nacional de Kiev. más de 5 años de experiencia en emprendimiento y creación de empresa, más de 10 años en experiencia directiva, en puestos de dirección de media y alta consideración, más de 20 años de experiencia en el diseño, implementación y gestión de operaciones de redes y soluciones de telecomunicaciones convergentes. Entonces vamos a dejar con la ponencia Golden Eyes Project a Don Tara.
Thank you very much. Thank you. Dear everybody, let me first of all thank you to organizers of this event, to JNCC for bringing us here, and especially me, and to CMM and Universidad Católica del Norte for hosting the event. Thank you very much. How do I proceed with this, right? Oh, thank you. Well, it's my pleasure to be here. It's my first time in Chile, and I must say that I was astonished by the natural beauty of your country when I was flying from Santiago to Antofagasta. And as the plane approached the city, I was even more impressed and amazed to realize how rich in natural resources the country is. And that's why the Antofagasta is probably called the capital of mining in Chile. And as somebody who spent a lot of time in recent years in analyzing remote sensing, I was also so excited about the opportunity to use remote sensing of different types, which we have implemented in our project in this area, because I was able to see with my naked eye that this area is rich in gold and copper and other valuable minerals. Why do I know this? It's because with this project, GoldenEye, it's a multi-year European Union funded project. We have been working with very similar challenges, and I'm here today to tell you more about this project. So first of all, this is the project which was funded in the scope of Horizon 2020 program. And the total budget for the project is more than 10 million euros for the duration of 3 years. So it's a very serious investment of European Commission into raw resources. This project was primarily focused on Europe, and we have 16 partners involved, among which we have 4 mining sites, 3 mining solution providers, and 3 universities and technological companies like my company. The project is coordinated by Finnish Institute of Technology, so that's why I was introduced that I'm in Finland, but this is the multinational European project, and my company is OPNET, and we are technical manager of this project, so responsible for the integration of technologies which come from all the partners into one coherent working solution, which solves all the problems that well-esteemed colleagues of mine who had this stage before me already addressed and covered in details. So in a few words, I would like to say that this project at the executive summary layer is to monitor and to improve the key performance indicators which relate to the mining operations. And this project is covering entire mining cycle, from early exploration, finding out where to drill, also improving the environmental footprint, less blasting, more intelligent decision-making, right? Also, it is targeted at the social acceptance of the mining operations, which are to reduce the environmental footprints, to make local populations more aware about what's happening, and to address safety issues for the workers, safety issues for the population. We have entire Europe. We have entire Europe covered in this project, as I mentioned, but the project is open-minded towards the rest of the world. This is not a typical research project. This is the research and innovation project, which means that it was only 75% funded. The rest of the funding had to come up from the participants of the project. which makes us all very interested to bring the results into commercial and real world exploitation. Because I, as the CEO of my company, also invested my own money into this project. So, well, let me tell you about this. Yeah, I really put my money where my mouth is, as they say. So first platform of technologies that I would like to talk to you about, and today we will talk about 3 layers of technologies that are being developed in this project, were developed and some still being developed, is related to the satellite sense. So in this project, we have used a large spectrum of satellite platforms. Of course, we use Copernicus, Sentinel-1, 2, 3, 5, and Landsat and MODIS, which are part of the Copernicus data set, which is available in the Copernicus Data Information Access platforms in Europe called DIASys. Maybe some of you have worked with them. So these are free platforms. Everybody can create an account on them and get the data. The problem is getting this data to the place where it needs to be analyzed. And this is not simple. One way to do it, as was explained earlier, is to copy all the data set to your location. Well, we have approached this in a different manner because in our project, we also work with commercial data. We also work with the UAV data, which was acquired specifically for the project by the project partners. So the traditional approach wouldn't work. So we created a platform that is joining, basically it's a hybrid cloud compute platform, which is providing high performance computing functions with the broad visualization layer. So as Felipe described in his presentation, that he had to use Google Earth, then process the data, take the data from the raw repositories of information, process it locally, and publish this in ArcGIS. So this platform is all of that in one place. So you don't even have to copy the data, the raw data, but you could process the data where the data is in the Copernicus data repository, but you can export and publish the process results, which are much smaller in the set, but could be used broadly. So I'm happy to demonstrate these platforms for you. I have it on my computer and on my lab, on my iPad. It works. It's agnostic of the platform because it's a web application. So that where the muscle of the platform, the real heavy computing happens at the back end, which is in Europe. But the delivery of the intelligent insights could be anywhere where you want. So it might be opportunity to explore this alternative way of building the data analytics platforms, even here in Chile with your university or with CMM. The next layer of technologies is use of unmanned aerial vehicles, such as drones, for in situ verification. So we generate our own verification data. We had a number of surveys conducted at each of the sites at different seasons, which we tried to coincide with the simultaneous acquisition of commercial data. So specifically, we found that the use of Worldview 3, which is not exactly Copernicus, but it could be accessed through the Copernicus contributing missions, because there is a contract between ESA and Maxar and Digital Globe for exchange of information, and some of this information is also could be available, especially for the research and demonstration projects. So that's how we take some of the samples of data, and then when we know that the method works, for some areas, we could order high resolution imagery. So whereas the Sentinel-2 could allow us to survey a very large area, the commercial imagery allows us to zoom in like with a microscope in the area where the mining operations are, or where the results are not very clear, ambiguous. So we could reduce the ambiguity by ordering commercial imagery. So some of the data that we have received could be measured up to 30 centimeters per pixel, which is very valuable when you're, for example, mapping the ecological footprint of acid leaching, for example, or when you need to examine the slope stability or the tailing dam stability on a smaller scale. So this data can also be used for validation of the general remote sensing methodology. For example, we have validated the approach in 2 sites already during the gold exploration activities in Bulgaria, in Paragorishche area. This is old, well-known historical area where gold was mined since Roman times and Greek times. And right now the area is being re-evaluated for the additional exploration and research is undergoing to validate the profitability of the sites. As you know, Europe is an old world, right? We have exhausted our resources ages ago. All the mines have been mined out, and the deposits that are remaining there are very thin. So right now the technology allows us to get and revisit those mining sites and get the resources still in earth. But how can we do it? We need to know exactly where to drill, where to extract, where to put the machinery. Otherwise, it would be prohibitively expensive. So at the same time, we are validating some of the very cool technology, such as electromagnetic sampling of the areas. So where you have the electromagnetic antenna placed on a drone and it flies and for misinterpreting how it exactly operates. But with this technology as depicted on these images, we could precisely locate the electromagnetically denser regions in Earth where the ores could be in higher concentrations. And then this new data is being visualized with the 3D technology that we have developed, and also with compared with the multispectral and satellite-based data, so that we could improve and validate these methods as well, resulting in better trained AI models, in finer tuned data processing algorithms, and solving many of the traditional problems that are plaguing this analysis. Maybe you already know how difficult it is to work with this data, right? And the last but not least technology is proximity testing. We have one of the equipment manufacturers, Sandvik, or if you are in mining business, of course, you know the name of this company, who is experimenting with the placement of the spectral sensors on the drilling machines. So the cores could be analyzed as the machines are drilling. And at the same time, we are using GNSS, geolocation, improved base cellular positioning for both on the ground and underground. So when the samples are collected, the location of the samples could be precisely determined, even in underground mines, which are some going up to kilometers deep. And some of the, I almost forgot, this is not our technology, but it's available from the Institute of VTT. It's time-gated Raman spectrometry. It's a novel technology which allows to place the camera in front of the rock wall and sample and determine where these thin layers of deposits are, so that with new machinery, these deposits could be extracted. This could be done even inside of the mine by miners themselves. So this is a portable apparatus which could be placed and used to scan the walls for the mineral deposits. And so far, this technology is proven to produce valuable results already. So how do we put this together? So as I told you, there are 5 field trial sites. So the first one is the exploration. It's an old area, mining area, where tin mines have been mined out maybe 200 years ago. So right now, this is exactly the place where we're testing technology to locate thin deposits and establish if they'll still be commercially valuable to extract. The data collection is ongoing right now for this field trial, and we are improving our mineralogical knowledge in this use case. In the next case, which we personally went on the field trial to validate, I even have a couple rocks with apparently golden speckles in it. And well, this is the area where there's old volcanic activity sites with these volcanoes that have been there 20, 60 million years ago. It's very hard to see and recognize them right now because this area of the mountains is almost completely eroded. That even qualified geologists are still having challenges in determining where volcanoes are. So the new method that we have developed combined the multispectral and hyperspectral imaging, including Sentinel-1, for example, which allows us to better see rock formations even under thin layer of the soil and some vegetation. So I personally helped to locate one volcano with our satellite imagery and the tooling that we developed in this project. Next one is the active mine in Roșa. It's a Roșa Poleni, operated by Cuprumine in Romania. So the challenges that they have is to explore additional location of the ore where it's still commercially viable. Because right now the main mining body, my main ore body was already extracted from the mine, and they are looking around the area where the significant deposits could be still located. Also, the operational safety and personal safety of the workers in the mine are of high concern there because of the road stability. So these huge trucks and excavators have to be operated safely. And we collected and reconstructed the complete 3D map of the site with the help of the satellite sensing technology and drone-based technology with the LiDAR, and then visualized this. And this complete 3D model of the mine was analyzed in details through the geomechanical modeling. And next slide is in Finland. So this is the mine, one of the older European copper mines. It's the underground mine with some of the closing activities going on. Right now, the mine is mostly given for researchers because the ore was already mined out, and it's undergoing the closure operations. So some of the challenges that are being solved there are tailing dam stability monitoring and ecological monitoring. So for example, next in the coming week, there will be a team of local groups who will do the ecological sampling of the area, select the samples from the water, select the samples from the tailing dams. There will be simultaneous satellite acquisition by Worldview 3 for the very high resolution, and simultaneous multispectral, hyperspectral drone flights. All this data would be again collated into one data set and processed in the platform with which we will better be able to establish the validity of our approach and algorithms. And the last one is the old site, which has been mined out maybe decades ago in Kosovo. And now it's a huge environmental hazard. They have many tailing dams and lakes there, which need to be monitored. But at the same time, they would like to see the possibility for the secondary extraction of the materials which are still in the tailing dams, which specifically goes for the rare earth metals and some of the components which go into microelectronic industry. So this is the possibility also for secondary extraction opportunities. And thank you very much on this. I would like to summarize that the project that we have right now going through, it's in the third year of the project. It's the final year of the project. The technologies have been already developed and are ongoing real field validations and trials. And so far we are getting excellent results. So we are looking forward for more opportunities to extend the applications of the technologies developed beyond Europe. And I'm here for today and tomorrow and available to conduct the demonstrations of the platform to those who are interested in person. Thank you very much. Questions now? Okay.
Bien, Vamos a proceder al montaje para el conversatorio, para que se realicen todas las preguntas y podamos discutirlas cada una de ellas. Por favor, Felipe, Jaime.
With the device, you can.
Oh, okay. Because I was on the phone.
Listen the questions in
Thank you.
English language. This is the button of volume. Button.
And they put it in my ear.
This off on.
I don't know how to. Could you put it on my ear because I don't know how it works. Oh, thank you. Yes, I can. Hello. So then I can leave the
Bien,
event.
vamos a proceder a la etapa de conversación, de discutir cada uno de los temas que hemos visto hasta ahora. Antes que todo, me gustaría que hiciesen las preguntas respecto de la presentación de Jaime y de Felipe, y si no, la hacemos de manera en general para todos. ¿Alguna consulta, pregunta en este momento? Bien, entonces vamos a iniciar dejándole la palabra a ver. Joven, por favor.
Well, my question goes to the presentation of the Golden Eye. I would like to ask, what's the most like the biggest challenge of making Golden Eye to being a system that that can work easily in the industry?
Right. Well, there are many challenges. So I can say, because I hear myself with a 2 seconds delay, so it really is not making my brain work well. So there are multiple challenges that I can see already in the consortium. One, of course, is more business. So how do we make successful business out of it so that the platform could be commercially viable? The same like it is with the deposits, right? Your resources, your deposits should be commercially viable. Same thing goes about the platform like this. We need to construct new business models which make the platform sustainable, right? So that's the biggest challenge on the business side. On the technological side, the challenges were quickly solved because we had been lucky to have a very competent consortium. I don't know if you noticed that we had a Sentinel Hub involved, we had technology providers involved, we have mining sites users involved, and drone operators involved. So that was really favorable. And we could quickly establish the requirements for the project and solve them with the technology that our company, for example, provided. So technologically, the project was absolutely a success, and we will demonstrate to you if you have more questions. The next challenge, of course, is the future challenges. And the future challenges, it's coordination between the data sources, acquisitions, and in-situ activities. That's why I was so excited about Chile, because our site in Finland, for example, our biggest enemy there is the weather. And not only the weather, but also latitude, because high latitude means that the sun cycle, the daylight cycle is limited. So the remote sensing methodology does not work there very well in winter because it's dark in Finland. So at the same time, there is a lot of snow and cloud cover. So yeah, so the technology has limitations, but at the same time, we could also see the benefits of different technological approaches like SAR-based approach, which is not afraid of clouds, well, unless they are volcanic, and combining it with additional in situ sources. But there are a lot of technical challenges that I can talk for hours, but these are solvable. The biggest challenge, in my opinion, still is commercial.
Thank you very much.
Matt, por favor. Aquí adelante, por favor.
Thank you. And thanks everyone for excellent presentations. I've really enjoyed this, and I hope everyone else has. My question is actually for Dr. Ortega. You were presenting us the monitoring of the movement of the tailing dams, and I was wondering if yourself or others, or if there's even possibilities to start to incorporate other types of data. And I'm thinking you mentioned a lot about the problems with liquefaction and overtopping through extreme weather. And I was just wondering if you can use other types of information. I'm thinking particularly climate precipitation, which you can layer to then start either predicting future risks or indeed actually even hindcasting where these structures have failed. What has been the parameters that cause that? And can you do any types of progression analysis to start understanding risk? Thank you.
I will ask in English directly. Sure. It's the problem is, what do you have for measure? In general, in a mine tailing, when you are measuring in active of the big company, you have everything. You have digital elevation models, you have piezometers, inclinometers, and so on, geophones, accelerometers. But the main question, what you can do when you don't have data? This is the main question. And of course, there in that case, there are a lot of possibilities to have another data, meteorology and so on. And the main idea is how you can create index of risk. This is the main objective of our project. Okay, how when you can say if something is in danger. Okay, normally I show a line where the wall is decreasing. Okay, but one question is, this decreasing is normally or normally? And this is a way, with the use of artificial intelligence, with the use of another one, you can prevent something. Okay. In general, the liquefaction process, it's very fast, but not instantaneously. In general, you have some predictors. Nothing happens in a moment. Okay. But when you saw the interferometry of Brumadinho, you can see there is an acceleration of the formation of the wall with start in September. And the question is, well, maybe something can do, or something you can say, no, here that happens something, and the people can do actions. The engineering is good. The people can do something. And of course, I think in general, at least for this kind of disaster, I think that it's possible to construct an index of risks in order to take measures. Okay, and of course there is the artificial intelligence is open. There's full of things, but we are full of data. We have data from anywhere, and the main question about the challenge is how you can use. And this is the big challenge, how we can use the data. The problem is not the lack of data. I don't know if somebody more wants to say something about that.
Recuerden que pueden realizar sus preguntas en español si lo desean. Hay un traductor que les va a comunicar la pregunta a los presentadores.
Hola, buenas. ¿Se escucha, verdad? ¿Sí? ¿Se escucha? Ahí sí. Buenas tardes, gracias por sus presentaciones. Mi pregunta es para todos y es, ¿cuál ha sido la mayor problemática que han enfrentado en el desarrollo de los proyectos, tanto antes de la pandemia como durante la pandemia? Gracias.
the main problems that you for make the projects after COVID and before COVID. So in some way, how the COVID affected the research?
Only the research.
For your project.
For our projects. Yes, thank you for your question. Actually, yes, we had, each of us, we have our own challenges. For example, my case study was in Greece. So for taking samples, I had to go to Greece and I was blocked. So actually, you mentioned to a very interesting question, because yes, it creates different challenges in different scales. For example, as I mentioned, I couldn't go to Greece and I had to ask people to make samples for me. And you know, when you want to make a sample, you have your own grid, you do calculations, you make optimization, and you go and you do your sampling. But when you are not there, you ask someone, maybe they are not so experts, and they do samples which are not exactly in those places and coordinates you want. So afterwards, for interpreting data, you have to face with challenges. You have to maybe remove some of them, which are like outliers. They did some errors during the sampling. So all these will affect your work. So yes, COVID, at least in our project, was affected in this way, but at the end we have to go on. So I could present just one of the challenges we have.
Well, yeah, I think COVID has impacted everyone in different ways. For my perspective, in terms of research speaking, I think everybody knows the impact, the bad side of the impacts of the pandemic and the COVID. But I would like to tell you a good thing that happened during this period, because everyone was isolated and on computer all the time. We actually had a chance to put a project together with Google Earth Engine and GEOS, a group on observation, to develop an application on Google Earth Engine for water quality mapping water quality. And then in 2020, we had a chance to focus only on this project and then taking courses online with other groups. And we had a chance in a couple of 6 months to develop some skills and focusing on the platform itself. So that's, I think it's one isolated good news throughout the pandemic. And then he had a chance to now use this kind of skill for different applications. So I think that's one good news about the COVID.
Thank you. On our side, I would put more commercial mind on it as CEO of my company. So every threat is also an opportunity, right? So while COVID indeed had a tremendous impact on our project, because our project really started with COVID at the same time. So we were not allowed to travel. We didn't have a formal kickoff of the project. We never met some of our collaborators on the project until COVID was over 2 years later. So, but on the other, we even lost one member of the consortium, one person in university, professor, who unfortunately died of COVID. So it was quite tragic. But nevertheless, as I say, every threat is an opportunity. We've learned how to work remotely. We've learned how to do work and collaborate without physical meetings. And also, due to the COVID, we got a 6-month project extension. That's a good thing. So we had more time to work on the project and the deliverables. So it gave us more time to do better job. But yes, I would like to remind you, always look, because I know that a lot of you study business here. Every threat is an opportunity. Indeed.
¿Alguna otra pregunta, por favor? Yo le voy a hacer una pregunta. Todos los trabajos, todos sus proyectos son muy interesantes y que lo han expuesto a todos nosotros. ¿Cómo creen ustedes que universidades como la nuestra, o la Universidad de Chile, pueden aplicar todo el sistema satelital de Copernicus para involucrar toda la minería dentro de este sistema de teledetección, donde podamos obtener mayor utilización de los datos satelitales?
Start. I think that's very interesting because we have shown different techniques, different ways to map and do some inferences about the minings and its consequences. And I think if you in the university take a look at some techniques that has been applied, we can adapt for your own purposes. And I think there's a lot of, for example, the GoldenEye project, it works on the platform on the cloud that can be the same scheme or same approach can be used for different approaches. I think that's the idea here is to show ways to do it, but also you can use that for your own issues or your own tasks. I think that's because the techniques are very similar around the world for different applications. I think that's more in the technical perspective. I hope your students they are aware of these techniques and can keep that on, right? Because also the education, it's important because a lot of techniques takes many years to learn. And if there's a message for the student, for the university in general, is to keep on and to learn these skills and adapt and learning how it works so you can adapt for your own issues and tasks. I think that's a message I would say. Thank you.
If I may add, in this project, in GoldenEye project, we have 2 universities involved. And we also, as a company, involved one, the bachelor graduate student who did his kind of internship with us. So he studied big data and AI, knew nothing about geology. In the result of 2 months working on the project, he learned the many methods, including AI methods, how to map gold and copper deposits, how to generate mineral indexes. And even within 6 months, he submitted an article to the Remote Sensing magazine, which is being published now, about the use of filtering methods on SAR satellites. This is an interesting work, which he was able to achieve just because he was from the university, but also because he had the cross-cutting expertise. So not only he was AI expert, but by joining the real project in mining, he learned new skills and applied both of them with a very positive result. So universities have this ability to do the application and set the trends for the rest of the industry to follow by developing new solutions.
Yes. Yes, I think a very important point here in Chile is your applications. You are a country of mining resources, so you are on the top. And the point is, when you have a lot of applications with very important mines, it means you have a lot of challenges, much more than us. because the scale of our works, they are very like a point in front of your scales and your minds. So it means you have multiple challenges. So in my opinion, just these presentations can be the starting point for you. So you have your own challenges, you ask from your industries, your minds, and let's say the final stakeholders, what are their challenges? And you can focus on one of these challenges, whatever you are more interested. You can just have a look to these methodologies which already exist, the tools, the softwares, all platforms, things that exist. And this can be your jumping point. So you can adopt it according to your challenges in your applications, and even going further, because of course your challenges are bigger, so you have a longer way to arrive. And I think this is the most interesting thing for each of you. And from the university point of view, I think there are always a lot of collaborations among universities. Fortunately, since maybe fortunately or unfortunately, we are not so much business people, so we only think about the research and the results. So it's easier to enter. You just can apply for some scholarships, or even if you have your own scholarships, there will be no problem moving among universities, learn methods, coming back and apply in your real case studies, in your applications, which I think it will be very precious experiences for all. And I think we will also learn a lot of things from you, because your challenges are real, and they will have an important economic effect for your country. So that's it.
Yo quería agregar algo, voy a responder en castellano. Primero que nada, creo que las universidades, al menos en el caso de Chile, son las que están llamadas a hacer innovación, a hacer ciencia, ¿verdad? No, la transformación tecnológica viene como resultado de hacer ciencia, y la ciencia tiene que nacer desde la universidad. Por lo tanto, ya sea una universidad grande, chica, pública, privada, yo creo que hay un deber en tratar de generar ciencia para resolver los problemas. La minería en particular tiene problemas que son muy clásicos. Uno de los problemas es que la ley que vemos en las compañías mineras cada vez más baja. Extraer el cobre o lo que sea es cada vez más caro, ¿verdad? Tenemos que ir buscar más en las rocas para poder encontrarlo, y por lo tanto lo que necesitamos es generar tecnología, generar ciencia, generar conocimiento, y eso se hace desde las universidades, pero no desde las universidades aisladas. Yo creo que lo importante es ver cómo generar grupos, cómo generar equipos, cómo generar interacciones, ya sea en Chile o en el extranjero, que están ellos, ¿verdad? Para colaborar, y esa es la forma de hacerlo. Alguna vez un amigo me dijo, Dios está en todas partes, pero tiene la oficina en Santiago, eso hay que cambiar.
Preguntas en el chat, Florencio. Si
Perdón,
tienes, por favor.
¿Ítalo puedo?
Sí, por favor.
Sí, voy a hacerla en español. Es una pregunta de Cintia Silva. Pregunta básicamente la aplicabilidad para casos chilenos cuando se necesita evolución en el tiempo. En particular, preguntan por disponibilidad de imágenes antes del 2015, por ejemplo. Yo sé que Jaime ha trabajado en esto, en particular en evoluciones de subsidencia y temas similares, así que a lo mejor Jaime puede responderle.
Respondo un poco y luego si alguien más, claro. Sentinel, el programa Sentinel comenzó con los lanzamientos 2014, empiezan como en régimen ya 2015-2016 tener imágenes. Hay satélites anteriores, en lo óptico están Landsat y una serie de otros que tienen una historia mucho más grande, no siempre con toda la disponibilidad y la revisita, Por otro lado, hay imágenes de radar anteriores, también está radar Sat 1, radar Sat 2, y hay algunas, ahora, no siempre en todas las zonas hay disponibilidad y no siempre son gratuitas. Entonces, la respuesta más bien, sí hay, pero hay que ir viendo un poco caso a caso. Eso ha sido mi experiencia. No sé si alguien quiere complementar. Possible clear image before 2015. Before 2015. Before 2015.
Sí, como Jaime desculpa, en inglés, como he told us, yeah, but there's a lack of information of high resolution because the satellites came to high resolution, spatial resolution came mostly in the 2000 and on. So before that, only Landsat and some, yeah, Landsat started in the 70s with a 30 meters resolution. And in 2000, they started a commercial satellite with high resolution, and then Copernicus launched the Sentinel-2, which is, and also the Spot one, right? That's the French Spot. Also from the 90s, there's some images, but yeah, there's a lack of information before that.
Yes, I also would like to add that in our research, we also use historical data sets from, for example, in geological applications. A very good data set is coming from the Aster tool. Unfortunately, this tool has ran out of coolant, and the latest years actually are inferior to the previous years of the operation of that satellite. There are some additional data sources which could be acquired from NASA. These are all also open repositories. You just need to know how to access them. I think you already do. So here a little I can add. But indeed, the technology which has achieved significant resolution only became available recently. And that's why it sets a pretty solid, firm horizon how deep you can go.
I just would like to add that combining the amount of satellite data that is available today, and then with the cloud computing, that is a shifting the paradigm. So we are now from 2015 onwards, we are able to process pretty much all the images on the cloud, and that really changed the game. And, we are able to map a lot of things in different scales in time and space as never before. So I think combining the two, the amount of data available and how we can process on the cloud, that is really significant.
Aquí hay otra pregunta del público.
My question is for Taras. I have been trying to frame the question in my own head, and I still don't have it, but so try to follow me. I'm thinking of geosecurity, because for the moment, anyone, anywhere in the world can access the satellite images, right? But to do all the field test or field sampling that is necessary, you always have to go to the specific country legal framework, right? So in the case of the EU, it's relatively easier because you share a common framework. And I'm thinking in special cases as Chile, Bolivia, Argentina, right? Peru, we have a lot of mining resources, and we depend a lot on international companies coming here and exploiting these resources. But once they come, right, they can have the idea that there's something, maybe using satellites or not. But once they want to do something, they have to ask for certain permissions, right? So how is the business model in your company and with the Golden Eye project company? I don't know if this is a project of the company, but how's the business process behind it? Because if you have, for example, I understood it as drones, these automatic vehicles that are sampling with biomagnetic things. How do you do it? Because there is something about geosecurity, airspace protection, and things like that, right? That will change country to country. So is based in each country, will you have certain agreements? I don't know.
Yes, that's a very good question. We even have a separate work package dedicated to this. This work package is actually starting right now, a lot of work. It's about industrialization and commercialization of the platform. So GoldenEye, and we developed the platform. So GoldenEye project and Golden AI, which pronounced GoldenEye, is the platform that we have developed. And our current vision, which could change in the next couple of months or quarters, depending on our research and results we get, is to keep the platform as a collaboration platform, which enables the data providers, data processors, and data users to come together like to a marketplace. And the rules and operations of that platform are governed by the existing regulations and laws in the countries where the data is being produced, processed, and exploited. So in European case, we have very firm rules about GDPR, about the privacy protection. So these rules put certain implications of what we can and what we cannot do. So for example, we cannot use super high resolution imagery with the personally identifiable information in it by EU law. But at the same time, the prospecting licenses are issued by the local government. So Chile is the party which is dictating how things should be done here, because this is your country, this is your rules, this is your law. And the foreign companies' mines that come here, the mining companies, they have to oblige, as well as we have to oblige. For example, if you order a drone flight, it has to comply with the local regulations. So that should be not some friend of my son flying his drone, doing the image acquisition. No, it should be a qualified, licensed drone pilot who gets the permission to do the overflights, and they do it at a certain time. So it's very regulated, and the platform is just an enabler, the way we see it. So by matchmaking the users of the data with providers and processors, we hope that it will create a vibrant marketplace. Did it answer your questions? Yeah. If you have more ideas, please let me know, because I know there are business students in mining here. So come reach out to me. I will be happy to discuss.
Tengo una pregunta más.
En función de la hora.
¿Hay una pregunta más desde el chat?
Sí, la última pregunta, Florencio, y la última pregunta de salón. ¿Ya? Por favor.
Sí, es para Felipe Lobo. Es una pregunta de Eva Carolina. Pregunta si piensa hacer algún trabajo local en relación con las empresas mineras de oro, que está en particular en Cerrado, en el estado de Goiás.
Goiás. Okay. Gracias pela pergunta, Florencio. He asked me if there's any plan to do a partnership with the Goiás, right? That's it. Actually, no, because to be quite frank, nothing against Goiás, because it's mining. Brazil, it's huge, right? So, but I think the technique we've demonstrated, we are able to map and do some mapping in Goiás state. But I think like over there is the type of mining is more industrial, and I think there's a potential for partnerships. Florenzo, if you can give my contact to the person, then we can chat on email and see what's the idea, because I'm not quite aware.
Seguro.
Gracias, Luis. And we'll chat more. But before this, I have a quick question for Jaime, because of sorry to break the rules. Because I was really interested in your presentation, and you showed about Brumadinho and all and then in Brazil we question these dams tailings, and then what kind of dams do you do here in Chile? Because in Brazil they usually use the proper material to build the dams, right? It's not super secure. And then I would like to hear from your expertise.
I talk with the people of geomechanics and the people of mining. I have a good friend who was the superintendent of geomechanics in Escondida. She told me it's not the material, it's the way, it's engineering. For that reason, if the river go in this direction, you never put the wall here. You need to put the wall there. And this was one of the big difference in the construction. I think the big difference is not the quality of material. Yes, there are a lot of engineering that, but the way to construct the dams is a key point. And some of the big problem was due to the way of constructing the dams. You never, as I told you, you have the rain this way, never put the dam here. The dam is in the other side. You must construct in contrary of the way to move the water. And this was the main difference. And in Chile, the law for construction of the dams is very, very strict. And there is a lot of surveillance that. This is a few idea.
Por favor, ahí.
Bueno, mi pregunta es si nos pudieran dar un consejo a la hora de innovar o implementar una nueva tecnología.
You can give an advice how you can innovate, how you create technology.
Yes, I'm starting to feel like I have the most airtime in this show. Well, second, Sarah had the longest presentation. So my advice, because I innovate a lot, is contrary to what you would read from the popular successful businessmen, which recommend to drop out of the school and then you become an entrepreneur. No, don't do that. Before you innovate, you should know the subject of your innovation very well. Try to get experience. Try to implement it. Start from the ground so that you know all the in and outs. The best entrepreneurs who are really successful, if you see them in this world, are those who went through every step of the way. Look at the Elon Musk, right?
Thanks.
Maybe I can add from the, let's say, research point of view. In my opinion, you can start, unfortunately, from your problems. Because when you have a problem, you have to become innovative because you should solve your problem. You have to fight against your challenge. So that was also my point when I said start from your challenges, because then you have to create some novelties. You have to be innovative because you have to solve the problem which your industry or your mind is facing with. So you will arrive to a good point.
Just to add, sorry, just to add, because yes, we need to solve the problems, but to get there, you need to quite understand all the what's happening, what are the status quo, the state of art, and which is not easy to get at this point and saying, okay, now I'm in position to make something more beyond what is available. That's innovation. And of course, with the programming and satellite, there's lots going on in remote sensing, and every day there's new technology coming up, and it's hard to pick it up, right? Because we need to study and then kind of be updated with that. So that's, I think, the challenge, to know what's available now, because you think it's something new, but China or someone in Europe, they already doing it. So it's difficult because of that.
I'd like to add one more point. And because you asked how to innovate, it popped up in my head, how to not just innovate, how to be the best innovator. Right? And for that, I can say that you should find the subject that you really like, subject that keeps you awake at night. And you work on that subject and never give up until you get where you want. Because if you don't like the subject, you will give up regardless. But if you do like it, make sure that you stick with it and get it done. Good luck.
Ok. Muchas gracias. No se muevan, por favor. Solamente les quiero agradecer a todos los que han estado presentes hoy. No podíamos tener mejores relatores que quienes nos asisten, así que un gran aplauso para ellos. Desde este momento yo termino mi labor de presidente de este seminario, de este taller de datos satelitales, Copernicus, para el uso en la gestión minera, de los recursos mineros. Algo clave, como dijo Jaime, las universidades son los lugares específicos para hacer la ciencia. Pero la ciencia no la hacen solamente los académicos, están los estudiantes. La innovación parte desde ahí, porque ustedes son el futuro innovador de este país y del mundo. Dicho aquello, dejo hasta aquí mi actuación como presidente y les voy a dejar con nuestro presentador. Un minuto, por favor, no se muevan.
Gracias, Ítalo, director de Escuela de Negocios Mineros. Vamos a hacer entrega de unos pequeños presentes a quienes estuvieron en este seminario, en este primer encuentro, a modo de agradecer su participación. Es por eso que a través de las manos de Ítalo Montopre hacemos entrega de un reconocimiento a Sara Kazmayansky. También para Jaime Ortega. Ataras Matseljuk.
Hello, thank you.
Muchas gracias.
Pleasure to be here.
Y finalmente a Felipe Lobo. Reiteremos por favor el aplauso a nuestros expositores, a nuestros panelistas. Los invito a tomar asiento, por favor. Tomamos asiento. Y para el cierre quiero invitar a Matt Smith para las palabras finales, ya dando por término entonces este encuentro de esta jornada.
I haven't prepared a pre-written Spanish speech, so I'm just going to go straight into English. Again, thank you for your hospitality. I think this is about my 8th or 9th visit to this fabulous country, and as Jaime says, I live in Brazil, so Latin America, even though I'm British, really is a second home. Thank you very much for my esteemed colleagues for their excellent presentations, the wonderful questions. I've been frantically writing down the ideas. It was great to end with the discussions on the innovation, and I think that's the thing to keep in your minds. I think this isn't, we have this technology, let's use it. It's we have this technology, let's develop it, and let's make, let's use it to make better decisions, make more informed decisions, and actually make more equitable decisions. I think we're living in a very, I think we've always, as humans, perhaps lived in a more interesting time, as we using the British interesting times throughout our collective history. But I think we're now coming into a point where, as Taras was saying, in Europe, resources are becoming depleted. We're making ill-informed decisions about the way in which we manage our life support system, which is this planet. So I would really encourage you to really take the lessons from this, go forwards, please do innovate. You have the contact details of us. You can certainly reach out to the project. If you can reach out to myself, Florenzio, Italo, you'll be able to get in contact with us. We'd be more than, well, we encourage you to continue this conversation. We really, really encourage this strong collaboration, not just between countries, but between, between regions. And we really look forward to hearing more of your ideas. I'm really looking forward to the rest of the week, and then at the end of it, really thinking about how and where we can support you, you can support us, and we can turn these conversations and these ideas into concrete projects which fundamentally make the present and the future a much better place for all of us to collectively live. So thank you very much. I look forward to continuing the conversation. Muchas gracias.
Thank you, Mark Smith. Bien, de esta forma estamos finalizando este encuentro de datos satelitales de Copernicus en Chile y América Latina, construyendo aplicaciones y redes de colaboración. Agradecemos la presencia de todos ustedes y a quienes nos siguieron a través de la plataforma Zoom. Les invitamos a compartir a continuación un cóctel. Gracias, buenas tardes.